Okay, good morning, everyone. Nice to see every one of you here. Some familiar faces. I'm Martha, for those of you who don't know. I'm with the academics team. And very good morning again for coming out on a Saturday. I hope you all had breakfast and coffee and we are ready to go. So, this session is about problem solving on the secondary level. And we hope that your takeaway today will be good. Great. Ask any question. Dr. Lai is here. So, feel free to have, pick his brains, if I may say, for some of your challenges. Yeah. So without further ado, Dr. Lai, we will hand over the floor to you.
Thank you.
Have fun.
All right, good morning, everybody. All can hear me? Loud and clear. It's a small group here, so actually I don't need a mic, but this is for the recording purposes. Okay, but that's why I don't hold any mic here. All right, this one is on the problem-solving strategies in secondary mathematics. Now, very simple three topics here. First of all, I talk about the problem solvers, okay? What does it take to be a good problem solver for the students? That's the first thing I will talk about. Then, of course, the main part of the thing will be in the second part, which are problem solving strategies. Now, that's where you see lots of things that we discuss, talk about, different types of strategies. And last but not least is that how to teach. Obviously, you know everything, but how to deliver to the kids. Eventually, is the kids supposed to learn how to solve problems? So that's basically, very briefly, just summarize it in this way. Oh, by the way, as I said, the workshop, usually when I run, is very informal. You're free to raise your hand and ask me any question. I try my best to address the question. So that's what I'm doing. All right, let's see. What it takes to be a good problem solver. Now, a good problem solver usually has some attributes. Some of these attributes is inborn. Some people somehow, they have certain abilities other people may not have. But the thing is that these attributes can be developed. The good thing about it is not if I'm not born with it, it can be developed. It's like develop any skills in life. So that's one thing good about it, okay? So students can say, oh, I'm not good at math because I'm not born with such a math skill. No. They can develop it, in other words. Now, let's look at what it takes to be a good problem solver. What are the attributes? We say, okay, so we look at it. Be insightful in concept understanding. The first thing, they have to be very insightful in understanding. Now, I make a point here. I say that having a good understanding of a concept or procedure is not good enough. When you show a kid the procedure how to solve a problem, they say, oh, I know already. That is not good enough. Yes, they know how to solve it, but not good enough. The first thing I talk about that, it's okay. They need to what? Cultivate insight into the concept or the procedure. That is far more important than just knowing it. All right, now, insightful understanding, especially for big concepts. By the way, no time to talk about the big concepts. I can write a separate workshop another time. What are the big concepts in mathematics? For primary, the primary math big concept. Secondary big concepts. And these are very, very important. Really, this concept will tie the other smaller concepts. So this whole idea. But today, I will not go into this big concept. But that's important. Once they know the big concept, very insightful, then it will build a strong foundation on the math skill in problem solving. That's a key idea. Now, let me give you one simple example. I'm sure all of you know this one. Now, this is one of the many big concepts in secondary mathematics, Pythagoras theorem. Okay, so they first learn it. They say, okay, given a right angle triangle, then they say that the square of the hypotenuse is the sum of the squares of the two legs. Oh, I know, simple. Whether they know how to prove or not, that's important. That usually you don't go into the proof of it. Actually, the proof is very simple. I can tell you this, okay? It's a three-line proof. Using what? Similar triangle. That's it. 3 lines. And not only that, they can literally map the squares on the two legs exactly into the big squares on the hypotenuse. It can match exactly. So it's very visual the way we look at now. Okay, I know it, but that's not good enough, as I say. It must be what? Insightful. This is my word here, right? What does that mean? First of all, they must understand that that characteristic, this one, a squared plus b squared equals c squared, literally characterize all right angle triangles, no exception. Why? Because there's a converse to Pythagoras' theorem. You know there's a converse. Huh? In mathematics, it's only a one-way implication. Pythagoras says what? If you have a right angle triangle, then this equation holds. Am I right? The reverse may not be true though. What's one thing about mathematics? The implication is always one way. But here it says, no, there's a converse. You can go the other way. If this condition is satisfied, then the triangle must be a right angle triangle. So the kids must understand that this is property characterizes all right angle triangle because of the converse of the Pythagoras theorem. First thing. But that's not good enough. They must know what if this is not an equation but rather inequalities. It also characterizes some other triangles. Of course, if you have inequalities, then these triangles cannot be right angle. And we know there are two types. Either acute angle or what? Obtuse angle. Now you can see that if I have the inequality the other way around, if the sum of the square of the two legs is less than the square of the hypotenuse, I get acute angle. And otherwise, I will have what? Obtuse angle. So they must understand all this relationship here. Not only this one here, this equation, or together with this, so that they can see that, this one literally can talk about, I can characterize all types of triangles, both the equation and the inequalities, the first thing. Any more? Of course. The famous Pythagorean identity. And that's very easy. The unit circle there, you can prove this one very easily. That's a very important property. They use it over and over in trigonometry. Cosine rule, later on when they learn it, do they see that cosine rule is an extension of the Pythagoras theorem? Is everything linked back to our dear Pythagoras? Even though, of course, Pythagoras did not invent the cosine rule, but that's the kind of implication later on people take onto it and they extend it further, into the cosine rule. Do they see that if I were to dissect the right angle triangle into two smaller right angle triangles, these three triangles are what? Similar. That is important. And not only that, they can see that if you were to square the heights, that is equal to the products of these two line segments. Now, that's what I mean by to be insightful in the concept of Pythagoras theorem. You follow me? Of course, fair enough. They don't learn this overnight, yes. Not in one lesson or two lessons. Over the years, as they go along, they can say, oh yeah, I learned this in my grade 7 or grade 8, Pythagoras theorem. Now this is how to link it back. They build their understanding on Pythagoras theorem. Now that I mean by to be an insightful understanding of Pythagoras theorem. Fair enough? Now, once you can link all this, you help them to do problem solving. Am I right? Definitely. We can relate back and forth, of all these little things here then. Hey, come on, you're free to ask me any questions. Don't let me carry on, all right? If something you either don't understand or you can disagree with me, fine, by the way. I take any disagreements. I've done it before. When some of the other workshops in other countries, they will raise their hand, they'll say that, I beg to differ. I said, okay, let me hear you out. There was one time I shared with one experience, it's very cute. It was a grade 6 textbook writers. And usually in primary school, they will teach to find the area of a triangle. Am I right? They will teach to find the angles of a parallelogram. Now, which one that you will teach first? What do you think of? If you teach to primary school, do you teach triangle first, followed by parallelogram, or the other way around? Triangle first, right? I said triangle first. One person said, no. It must be what? paragram first. Huh? So what do you say? Very cute, you know. They will say that, and later on they realize where they come from. Actually, in a textbook, they really do paragram first, followed by triangle. The reason is because they have learned rectangle, am I right? Square and rectangle first. They say, well, if you talk about the paragram, it's only slanted. That's it. Very natural. They can see very well, and they can do that very easily. Whereas triangle, they say, it's a bit harder for them to visualize. So by the way, that's very cute. In the whole group there are two camps, you know. One pro triangle first, one pro paragram first. And then they debate back and forth there. And I was standing there, you know. Unfortunately, you know why? Because they speak in their own language. They speak either in, I don't understand what I'm talking about. Okay? I was in Azerbaijan. They speak Azerbaijani, which is their own language there. I was one translator next to me is a lady, you know. There's a very cute lady there. So I was just there and after I asked, what are they talking? They say, they're still debating, you know. So finally, I said, my time is up because I can finish all my lecture here. I said, wait, this is a chicken and egg problem. Which one comes first, chicken first or egg first? Am I right? By right, what they say is correct though. You can teach area of a paragram first, followed by triangle. Because you know why? Because the way we do it, we say, we cut the little triangle, paste on this, it becomes a rectangle, right? So therefore, you know, so that's how we do it. And therefore, if they know the triangle first, they ask the question, how do you know that the piece that you cut is a congruent to the other side? Congruency will come in. You see, these are the things they will debate among themselves. So you can see that in mathematics, the different ways of looking at all those concepts. Fair enough. Sometimes it's not a matter of right or wrong, it's a matter of whether people can accept it. All right, so, okay. So now, this is meant by being insightful in concepts. One thing about learning mathematics is to try to cultivate creativity and flexibility. Now, what do I mean by that? First thing, they must learn how to connect ideas. I talk about how to connect ideas. One of the things in mathematics among students, they fail to connect ideas. They tend to learn mathematics in silos. This is algebra, okay? This is geometry. This is probability or statistics. They never know how to connect the ideas. Actually, mathematics is all interconnected. That's one thing. So you as a teacher must know how things are connected to each other, okay? They shouldn't learn it in silo. And therefore, because of that, if they connect ideas, they will explore what? Multiple ways in problem solving. The same problem can be solved in more than one way. Put it this, okay? Now, let them experience different types of strategies. I'll talk about strategy later on then, all right? And approaches. And don't be afraid of any unconventional methods. Be brave. Don't worry, oh, teacher never showed me this. Can I do it this way? You try and see. If what you do makes sense, it's logical, even though it's not covered in the class there. You show teachers, hey, by the way, I do it in this way. What do you think? And who knows, you know, the kid may have something more insightful, he will come with something different. Fair enough, so we allow that. And it's good to talk about what? Open-ended questions, which are more than one answers, or something what? Non-routine questions. Look at this question here. Now, this is a geometry question. A rectangle is composed of 3 unit squares. Okay, you see 3 unit squares. And I superimpose what? A right angle triangle ABC on it. And you can see that CD, B are actually the vertices of the unit squares. The question is that, what is the area of this triangle ABC? So the kids look at it, how would they approach it in the first place? Oh, triangle area is simple. Half times base times height. They know that, right? Good. Where's my base? Where's my height? Obviously, they will look for what? This is my base, this is my height. Correct or not? Base is easy to find. Oh, I have learned Pythagoras theorem. Good. The height, AC. How to find AC? Now, that's where the problem there. So these are a bit non-routine. Okay? So, yeah. I'll just share with you. So once in a while, you give them this kind of a question and see how will they do it. to challenge them. By the way, this problem can be solved in more than one way. Someone is, I can use trigonometry to find the angles. Oh, fantastic. Because they can find which angle. They can find this angle, right? So they can find the angle. Then I can find this angle. I know this angle. I know this angle. I can solve. So somebody can use trigonometry, or I can use geometry, whatever way it takes. So that's the whole idea that, give them, not always, because you give always, every time you give them this one, they will find math is really difficult. Once in a while, come into challenge, but let them work in pairs, in the group way, they can discuss, a bit more fun for them to, how to do it. They have different ideas. Sometimes among them, they will share ideas, put it this way. All right, so never mind, you can think about it later on then, how to find the area of triangle ABC later, okay? Now, adopt a problem-solving framework because students need to have a framework to solve problems and not very haphazardly. This whole idea. And of course, I will talk about the Pólya's method, as you have heard of it, the George Pólya's method, okay? I will touch on that one. Now, apply thinking skills and problem-solving strategies. These are the part in my second topic there. I will cover quite a lot there. Let them play some logic puzzles. It's good to play some logic puzzle or games. You know why? You need to develop their thinking skills and reasoning skills. Logic puzzle is very good to deal logical thinking and reasoning, put it this way. So these are the key ideas that you can do it. All right? I'll just go through very quickly this one. Take this one, very simple. You ask them, how many squares are there in this shape? Okay? Now, of course, they can finally they can find the answers. The question is not about the answer, though. Their thought process. How they count, that's what I want you to know. Do they count randomly? And then eventually they get an answer, happily. No. How are they going to do it? Is there a systematic way of counting the number of squares? That is my question. What strategies do they apply? So these are the kind of questions there. Actually, in solving mathematics problem there, not so much about the final answer. It's the process that matters. Am I right? It's the thought process that matters. So that's the whole idea. How they count the number of squares as such. All right, you can give it to, what grade can do it? Grade 7? Hello? Is it grade 7? Counting squares, it's only counting, there's counting. Serious, counting. All right, how they count. And you'll be surprised that they all count differently. The way they do the counting can be very different. At the point, but okay, A do it this way, B do it that way, C do it that way, C. How they do the counting and share with the whole class. So these are the whole idea about, try to develop the logical thinking and reasoning skills. Am I too fast? Okay, yeah? Okay, anyway, this is... Now, one of the things there is to attend to details. That's one of the things kids sometimes they don't bother with the details. They want to hurry and finish up the question as soon as possible. Don't worry about the details. Once they finish, finding probability 1.05, teacher, I'm done. Happily. So that's it. So they don't bother to check whether or not that is true, you see? They're supposed to critique every step of the session very meticulously. Be your own self-critic of what you're doing. In fact, many a time, I myself critique what I'm doing. So, hey, does it make sense? I change again. All right? So, and also try to relook the student process from a different perspective. Just now the question I showed you about the right angle triangle there, I look at it from at least 3 different perspectives to figure out. I know the answers there, but now we're looking at the same problem there. So it's good for them to explore in this sense, okay? Yeah. And also, once they're finished, they're supposed to check the solution against assumption given in the problem there. Sometimes they don't bother to check. They're satisfied the given condition. So these are the kind of thing, we want students to attend to details. All right, just very briefly. I will give a handout at the end of the lesson there. Now, one of the things there is that I want kids to develop perseverance. That's the hardest thing, to be very honest. In today's digital age, then kids doesn't persevere, unfortunately. They want instant gratification. They look at it, not more than a few minutes, teacher, how to do it. Very common. They don't want to think very hard, you know. So I think that's the whole idea. Now, perseverance is not about what? Work harder. No, it is not. It's about what? Work smarter and try to maintain motivation. So how can you help them to develop perseverance? There's a mind training that's important. If I train the kids, the mind training, strategic approach, and also the environment, the teaching environment, how you teach them. That is a key idea. Oftentimes, kids, when they finish the problem there, what they will ask you, teacher, is answer correct? You know what's the standard answer? Who cares? Serious, I don't care about the answer, whether right or wrong. I mean, if I don't look at your process, why should I bother about your answer, whether right or wrong, you see? So there's a whole idea. Now, what do I mean by mind training? That's what I'm talking about. You try to cultivate a growth mindset. You know the growth mindset? It's a positive. You see, many times you think that the mind is what? It's fixated. I fixed already. Fixed mindset. I cannot change. That is a danger. Sorry, teacher, you know, my mind is already fixed. I'm not good with math. It's fixed already. No. Your mind can grow. It's not fixed. That's just a growth mindset. The whole idea. All right? So you can probably questions, you know, about if they make a mistake, don't worry about it now. One thing about making mistakes, if they would struggle, it's normal. Teachers have to struggle very hard. It's normal. I'm not ashamed to tell the people that even I myself also struggle sometimes in solving some math problem there. So that's important. No, struggling is not a bad thing in learning. Do you know that some of the great mathematicians, to solve a problem, to prove a theorem, take how long? Years. Not one day, years before they find the final answer. Put it this way. Now, along that period of time, there also lots of frustration, lots of errors which they have made. Oh, sorry, it's wrong. I'll go back and then look again, start over again. Serious. And that's how it is. So it's very normal to struggle in learning. Actually, not only in math, in every subject. In English, in science, sure. No pain, no gain, put it this way. Am I right? So that's what I did there. Try to incorporate break the problem into manageable steps. That's important. If the problem is too difficult, break it down. Chunks, small little one. Part A, part B, part C, slowly. Break it down for them. It's almost like thinking, okay, first step, second step, another step. So this is a way to help them manage a so-called a difficult problem. One thing about students, they find difficulty in solving a problem. But somehow if you guide them to solve a problem, eventually, step by step, okay, they will do it. You know what happened? You build the confidence. They feel, hey, I can do it with your guidance. So that's important about the growth mindset. That means the mind is not fixated. I can grow. I can develop my mind. You know? So this whole idea, the whole idea, I talked about earlier on, talking about open-ended, you know, or non-routine question. You can do that, you know. Foster a supportive classroom. Students were afraid of making mistakes. I say, no, don't be afraid of making mistakes. We all make mistakes. Including I myself also make mistakes. But please don't make a fatal mistake. Fatal, you have no second chance, you're gone already. Making a mistake in mathematics, problem there is not fatal, by the way. You are still alive. Okay. How I define mistake? Mistakes provide opportunities for learning. I turn around, making mistake, positive. Mistakes provide opportunity for learning. You are better. So that's the whole idea there. All right? Now, last but not least, incorporate real-world problems. The problem in mathematics is that kids don't see that math is real. I do that because I'm going to pass the test or the exam. It's almost that math is a necessary evil. I must do it no matter what. I must face it. But after that, happily, I forget everything about mathematics. No, math is real in the real world, by the way. They need that. So it's good to incorporate some real world. There are many things that we can do to incorporate the real world there. I will show you one question later on, okay, about how to incorporate real world questions there. Now it's a very popular quote from Einstein. I like this statement here. It said, if I have 1 hour to solve a problem, 1 hour, he said that, okay, I would spend 55 minutes thinking about a problem and 5 minutes thinking about solutions. You see? Perseverance, that's what it means. 1 hour, I don't solve it, I spend a long time thinking about it, then eventually I will think about the solution process. That's what he says. Now, all right, so that's the very first part. Very quickly, I just go through this with you. Now I come to this problem solving. Now this is a part which I take most of the time there, all right? When we talk about problem solving, I give you this simple mind map. I talk about not so easy problem. Easy problem, don't be so sophisticated. 2 times 3, you don't need a strategy. Everybody know how to do. Of course, kids have problem with the simple thing. 2 times 3, they said problem, I don't know, okay? It could be. And I was told that even the secondary, they got problem with some of the basic algebra. Am I right? Okay, I'll talk about the basic algebra later on there, all right? But also need the content knowledge. So you have something not so easy, non-routine, whatever that is, you have the content knowledge, then you need 2 things. You need a process, that's what I talk about. The George Pólya's problem solving framework, the 4 steps are there. I'll take you through the 4 steps with example here. But you need tools. Thinking skills, strategies, these are tools. So these 2 must use in combination to solve any not so easy problems. So that is my man. Now let me start with something very simple. Basic algebraic operations. I heard from you people telling me something, oh, you know, my kids don't know how to do expansion, factorization, blah, 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 so on and so forth. Am I right? Okay, so let me go a step backward, talk about some of the basic algebraic operations now. Standard algorithm, do expansion, am I right? Can they do it? Some can do, some may know how to do it. If they cannot do it, then how? You practice 10 more times, you can get it done. They can do that, but they feel very, like very torturous. Can we give them a different way of looking at doing the expansion? I call it a non-standard algorithm. And give them a box. And they put it down there, and they start what? They will start doing the multiplication. Right? Then they start what? Adding up. You see that? I take care of x squared first, followed by the x, followed by the constant. These are my answers. Straightforward multiplication. You see that? I don't miss anything there. It may not be always 4 by 4 if you have three terms here, it'll be longer. This idea comes from where? Because in primary school, they learn this in doing what? Multiplication of 2-digit numbers by 2-digit numbers. This is called the lattice method. And then they will learn about place value in the primary school. So this is a place value to do the multiplication in this way. Okay? So they will have, now it's algebra, yes, but in primary school, these are numbers. And this is how they would do a 2 by 2 multiplication. Usually, when they teach them, they use what? We call it the column multiplication. Am I right? And that's where kids having problem in the primary school. They can't follow where to put the numbers there. So they use this lattice method, or the rectangle method, which you call that, to do it. But if you were to look at expansion here, basically, if you look at your x squared, your x, and 4, they are almost like what? Place value. Am I right? Place value. That's it. It's as simple as that. So once they see that, so from the idea which they learn in the primary school, they can use the same strategies, but on algebra now to do it. Easy? Okay, that's very easy here. Okay, now. You want to try this one? You can try and see what happened now, come on. Simple. Just get it done. Come on, just try it. Can you do it and simplify this one here? Just draw a box there. See what happened? Got it? The B part. How about the B? X squared minus x times 4x plus 7. How many columns you use? 2 columns or more? 2 columns or more. You going to put it down for me? How to do the second one? B part.
2 columns only, right?
Can you show it to me?
Yeah, because just now you mentioned if there are 3, then only 3.
Okay, good. If that's 3, that's 3. Okay, fine. Oh, I accept you. Okay, fine. Okay. All do it the same way? Agreed? Anybody do it in more than two columns? No. None. Okay. If you look at just now, I don't know whether you noticed which I have done earlier on. I'll show you what happened now. You see, I don't have the line here. I add in this way, diagonally. I get that out. If you add it this way, diagonally, okay, x and x squared, you can add together. Am I right? So, now, actually, I can put it in 3 columns. How to do it? How to do it? If I want to do it in the I can do it in the 3 columns. Anybody done the 3 column? No. 2 by 3. Yes. Yeah, that was 2 by 3. Now come show me. Come. Okay, our friend did the 2 by 3. Let him show you. Okay, good. Never mind. I want to sit here. It's easier to come in and out. Yeah. Okay, good. You see that? That's how you can do it. Usually, when I do that, I will put a 0 times x to make sure that it's consistent. So in other words, they can see that I know. You see, these are like the place value. Am I right? The hundreds, the tens, and the ones. Very much. So it's exactly what that is. So even though the kids can see that, there's no x here, but they know that the x, they accept that its coefficient is 0, and that's it, that they can get it. And they can still add it diagonally. See. So I always do it quite consistently. They will still get the same answer at the end of the day. So that's how it can be done. But of course, this is nothing wrong with it. Because this one, what she had done, she add up all the boxes, which is correct. Nothing wrong with that also, to be quite honest. Okay? The reason why I do it that way, because I emphasize, I depend on what they learn in the place value in the primary school. When they come to grade 7, same thing, I have to do it. Because that's how they will do it. They do the addition diagonally in primary school. So I follow up with what they have done in the primary school. I do the same thing in secondary. Fair enough? Okay, any questions? I mean, this is a very simple thing, but now, you think that if kids have problems during the expansion, this will help them in some way? What say you?
Question.
What?
So you take the algebra as a length of the rectangle, is it?
The number of boxes there. Yeah, correct.
But we're finding the area, right?
Find-
So
In a way, it's like finding the area, you're right.
those terms represent the length of the...
In a way, you can say that, yes. If you plug in the values, it actually becomes the length, you're right.
So the thing is, if I look at only 1/4 of it, that there's a -6, then the student couldn't get it. Then there's no length of negative.
No. You're right. Because the only thing that they had not learned negative area. So therefore, we only use a lattice to help them to do expansion, that's all. Okay? We never use it to find the area. Area is a different thing altogether. I know where you're coming from. If you're looking at from what they learned in the grade 7 about finding the LCM and HCF, that is where the length concept and the area will come in. Okay? They all learn LCM and HCF in the grade 7. Am I right to say that? Now, so they learn how to find the LCM, they learn how to find HCF. I pose a question. How these two concepts are related to each other? Now, this is not in my slide here. You have HCF, they have learned. Let's say HCF of any number. This I got a 12 and what? What do you want? 30, for example. Okay, then I add the LCM. Same thing. So your HCF of your a pair of numbers, LCM a pair of numbers. How these two concepts related to each other? Now, there's something. Are they related to each other, or they have no relationship at all whatsoever? That you think about that, and that's where the area concept comes in very strong over this matter. So you can extend it further. So now today I won't talk about this one here. That will give me another time. When I talk about teaching the concept in the secondary math, there I will cover some of these topics in LCM and HCF. Now today I'm talking about more of algebra. Okay, seems the algebra is a headache for some. I don't blame them, because actually in primary school they only have one module on algebra in grade 6. Yes, I think now the module has been moved to module 5. It used to be module 1, but they just say it's hard for the grade 6 students to understand algebra, so they move a bit later. It's fine with me anyway. It's not a big issue there. Factorization. A bit harder, am I right? Yeah, factorization. Of course, I do it by inspection. Oh, that's easy, I can do it by inspection. Some kids cannot inspect, and they don't know how to get this thing here. Is there an alternate way of doing it? No. Okay. Okay, my lattice will come again, you see, happily. What do I do? I put the x squared in the box now. Now I put the back, not outside. I put the x squared, I put the 6 here. What do I do next? Now, the 5x is not in there yet, okay? We know how to put the 5x. 2 things I would do. Multiply and add. Now, what to multiply? Look at the 6. How can I break down my 6? All the factors of 6. Easy. 1 times 6. 2 times 3. 3 times 2 is the same thing, by the way, okay? So just the 2 times 3. Okay. So what happens? I'm supposed to what? Add. What to add? 2 and 3 add to the 5. Am I right? I need a 5 there. So therefore, I put a 2x there. And therefore, the last one must be a what? A 3x. Am I right to say that? Then after that, what happened? How to get x squared? X times x lah. What else? Am I right? Now, once you get that, then at the bottom, you must have a 2. Fair enough. You have no choice. To take a 2x, you must have 2 times x, right? So they know all this. You fill it up there, and that's the answer. Am I right to say? So they fill in these two first. Forget about the middle. Then they try to make up the middle, they multiply and they add. Okay, how to get something, a number add to be, I see a 5. Oh, now I can put a 2 here, I can put a 3 here. So 2x and 3x. Can they put the other way around? Same, no difference. Whether they put a 3x there or up there, it makes no difference. Oh, this one is easy. Because this one is a monic. That means the coefficient is leading coefficient is 1. Am I right? But what if it's not 1? Oh yeah, this one, worse still. Oh, okay. Your famous cross multiplication will come in. Okay, you tell them this one and how to do it, blah, blah. I think kids are a bit confused by this one here. Am I right? This 6 is a troublemaker. Once you do it, happily you write this one. But the kids say, hey, teacher, how to get a 3x minus 5? How to get a 2x plus 3? You do this one. Teacher, how to do this one? So that's the whole idea. They get very confused by all this one, right? So it's okay. Let me find an easier way for you. What should I do? And my box will come again. Well, my box is very useful. It's a universal tool I can use in different things, okay? What I do? Well, same thing. You know I put the x there, so I put a 6x squared there, am I right? Then I put a what? A minus 15. Now, remember about the two things? I multiply and I add. What do I multiply? 6 times 15 is negative 90, am I right? 6 times negative 15 is negative 90. Then I start looking for all the factors of 90. I write it down. Not many, by the way. This is all I can think of. No more already. I have one side positive, one side negative. It's okay. Don't worry about plus or minus. It's the same thing, though. Don't confuse it with one. There must have plus or minus there. Then the list will be much longer. Don't do that. It's the same thing. Okay, so I have all the positive on one side. It's the negative. I have all the negative in one side. Now, what am I doing now is this what? I must what? So, first of all, I multiply, right? Then after that, I look for a pair that will give me a what? Negative 1. It's the last one. Am I right? It gives me a negative 1. I need a negative 1, right? Oh, so here's my negative 1. Okay, good. I'm done. Once a negative 1, then I know where to put in there. Then once I do that, the rest is a lot simpler already. So then I fill up the rest, and then go to find the answer. So the box helped them. I mean, this method is good. I mean, I would say this method is not good. Some can do it. I don't mind. They will do it. But I'm talking about for those who can't do it. Then we must give it another way of doing factorization, obviously. So if they do it this way and get the answers right, it's perfect though, nothing wrong. Nobody said that they must do by cross-multiplying before they can get the right answer. No, sorry. If they do it this way, get answers there, full credit. Okay? Well, now you want to try some for yourself? Come on. Let's try. Now, you try now, this time. I'm talking about very basic algebra here. Okay?
Should be correct.
You ask the kid to circle the right number yeah, that's right. So the box will remember this one and they will do it, you see. It's for the student's sake that I'm talking about. Yeah. Anyone know? Show me the A. Ladies, the 3 ladies here, come on. Anyone? Volunteer? Come on, show me how to do the A. Okay, thank you. All agreed? The same answer, right? Okay, easy, this one. How about second one? Anybody? Any of the 2 ladies, anyone want to try? Come. You come and show me the second one. B part. Doesn't matter? Slowly, don't worry. Oh, you do cross marcation. Oh, I see. You do cross marcation. Okay, never mind. Okay, anybody have done it? It's all right, don't worry. Anybody have done it doing the box method? Any volunteer? Nobody take up this one? How about the gentleman behind? Have you done it? No, not yet. Ladies, have you done it? No, also can. You've done? Okay, our dear friend have done. Okay, good. You show me. Hey. Stephen, I better sit here and climb up and down. Easier for. Okay. All right. Well done. All right. Same answer as this one here, right? Now, of course, one thing about this, of course, you can do it very fast, but the poor kids have to do it right, one by one. 1, 2, 3, 4, 5. They may just write down all those whatever that they can do. It's okay anyway, right? Yeah, but because now you can spot straight away which pair to pick. But for the kids, they write now. Then they put, oh, this pair, or the circle this pair. So fair enough. So that's how you do it now. So now you see how this is being done? You see, actually what he can do, he can expand all the way down if he wants to. You know, am I right? You can put down 1 times 1 over and then 2. Because this one is divisible by 1, by 2, then what? 3 cannot, okay, 4, okay? Yeah. But once it comes to the 4, straight away he can see that, you know, I can do it already.
The 104 is
104 basically is like 8 times 13.
from there you need to factor.
Yes, you will just put it there as such. So that's the whole idea that he will do.
I come across a student having a very different way. So that's why I try to understand, but then I couldn't remember.
Ah, I see. Okay. So that's how it is being done. All right. Yeah. Then slowly, you just practice a few more times, then you will get in the hang of it then. So that's how they will do the factorization, all right? Using the same, you see, I take the same boxes to go through, doing all those things there. Now let's go on to a bit further. What else have they learned in the basic algebra? Division, am I right? They learned this one? Long division. Oh, by the way, long division also poses a problem for primary school kids. I guarantee you. Okay? Of course, we know all this. That's easy, So but the kids sometimes also have, because they got problem with the long division in the primary school. When they come to a secondary, do the same old long division, except now this is all symbolic. It's even worse. But if you look at it, it's almost like doing. Remember when they do the primary school, what time do they use the long division? Place value. Place value is one of the big ideas in primary mathematics. It's very important. Literally from grade 1 to grade 6, place value is used repeatedly across. So that's quite important. So in that case, the idea of place value in a way can be applied. Of course, these are not place value. Fair enough. We know that. All right. So, but the idea is quite similar to what we do in a long division. But if they cannot do this long division, what can they do? Can I give a non-standard algorithm? Hey, again, I can do a little box there again. This 2x2 box is quite useful. I can do many things. This is my divisor. Am I right? I put my divisor first. Now, if I put my divisor here, that means this must be my quotient here. Am I right? Then this part here must be we call that what? The dividend. Okay, the quotient, the dividend, the divisor. Okay, so this is a term we give to all this. They have learned that also in the primary school. Now, what to put inside there now? I'll put x squared first, slowly. So if I put x squared, what do I do? Of course, then I know that one of the terms in the quotient must be x. Am I right? Now, if I have x there, then the one at the bottom, it must be what? Minus 5x. No choice, what? Because basically I'm doing the multiplication now. You know what I'm doing? Actually, I'm reversing division to what? Multiplication. I'm using multiplication to find the quotient. So if I put x there, then I know I just have no choice but to be what? Minus 5x. Because of minus 5 here. Am I right? Okay, now, next is what? I must figure out how to get the what? Negative 13. Correct? I have a negative 5x already. Remember how I add? I add this way. Remember I add this way? So this must be an x term here somewhere. So I must put something there to get the negative what? 13. Am I right? What can I do? Oh, I know my arithmetic very well. The kid will say that. That's it. Correct or not? Now, once they do that, straight away they can figure out, I must have a negative 8 here. What else can it be? It must be 40. Oh, good. Okay, so everything is done. So straight away, my quotient is x minus 8. This is my quotient. This is my divisor. This part here, everything is my dividend. So in other words, the trick is that they put this term here, they look for the first term of the quotient, must be x, no matter what, okay? Then this becomes 5. Then they try to make the negative 13x. Make it add together must be equal to negative 13x. So it must fit in the negative 8x here. Once they do that, they fix already. You see that? So that's how they would do it. Easy? Okay, now by the way, you're free to take a phone to take a shot of my slide if you want to, by the way. Feel free to do so, okay? Yes. But I know I'll give you a hand up, but in the meantime, if you want to, you can take a shot of it first. What do you think? You think it's easy for the kids to learn to do the division?
Better understand.
Huh?
Better understand.
Better understanding, huh? What goes on, huh? Yes, okay. This one is very procedural, am I right? Yes. Okay, let's look at that. How about look at another one? Wow, this again is harder one, huh? Because now my coefficient is no longer 1. Here it is it's an x already for the coefficient of the x squared. So how should I do it? Oh, same thing, by the way, since I've done it for the easy one, I will do the same thing. But you see, this one, I got the remainder though. This one is a complete division, no remainder. But then I got a remainder. Well, my box electric can also give me the remainder. Oh, much longer now, my box. I tell you why, okay? Look at my box, why is it longer now? First of all, same thing, I put down my divisor. I put down my first one, 8x squared, am I right? 8x squared, I put it down. So therefore, straight away I can figure out the first term of my quotient. 2x, fair enough? Now, once I've done that, of course, the one at the bottom must be what? 6x. No choice already. You're forced to get 6x. What comes next? I see inside there, how many x are there? 26, am I right? But I only have 6x. But I need 26 x's there. So how many do I add in? 20 more. No choice. 20, right? I know how to get 4x to 20x times what? 5. Okay? Then with that, I got 15. But hey, sorry, there's no 15. It says negative 9, right? So that means I still need to subtract negative. That means I what? I've gone over. Supposed to get the 9 minus 9, but I got to 15, am I right? So I have to what? Subtract. So that is my remainder. Am I right? Something extra. I take away. So I have extra 6. That means when I do the subtraction there, I end up with an extra 6. So therefore, my quotient is the same as this one here, 2x plus 5, and my remainder is 6. That's how they figure it out. You follow me? Something extra here, extra means what? You have this. Something it can be positive, it's below, then it becomes, But usually, remainder is always a positive number. Never be a negative number. Am I right? Am I right to say that?
The remainder is always positive.
Am I right? I'm asking, am I right? I ask a question. Or am I wrong? Well, confused already.
I haven't reached there.
Yes, the remainder is always positive.
It cannot be negative? Are you sure? You think very carefully. That is where the whole issue is. Yes, only if they are numbers. In primary school, when they do the long division, the remainder is always a positive number less than the divisor. That's a fact. If your divisor is 5, the remainder can be at most 4. Either 1, 2, 3, or 4, and it stopped there already. But in the case of algebra, you don't know what the x is all about. So there are times that the remainder can be negative. Bear that in mind. We should not let the primary school, the numbers carry into algebra. That's where it differs. You see that? Okay, never mind. This I asked you the question there. Am I right? Okay. Okay, you try this one now. Come on, you try the division now. Come on, you do you said I do it, now you do it. Then you show me how you do it. Yeah. Okay? All agree? Okay? That's how it's being done. Okay, so you fill up the what? You do the x squared first, am I right? You put it down there. Since the divisor is here straight away, you can fill up this one first, am I right? So exactly, this is the first one, you do it, you follow by this one, then you just make the difference for negative x, you just negative 2x, you have put a negative 4x here, then after that, the rest just follow up nicely. So that's how it's being done. So the approach is this, you go this way, this way, this way, and this way, and that's it. Okay, B part, anybody? Ladies, want to try? Want to try? No? No? Want to try the B part? Cannot. You want to try the B part?
Can.
Oh, can, okay. Let's see how you do it.
So first of all, we put in the x square.
Yes. No, they put the divisor there first. Divisor.
Yeah.
X, 9, that's right.
And then to get x squared, of
Yeah.
course this is x.
Yes.
And then,
It was the 9x, correct.
yeah. And then next one is 15x. We want to get 15x. So 9x plus 6x, we can get 15x. Alright?
Yes.
And how to get this? We have to, yes, this 6 times x equals to 6x. Then 6 times 9 equals to 54. Okay? But we only have 46. So 54 has to minus 8 in order to get 46. Okay.
So it's over, right?
Yeah, that means this is the remainder.
The remainder is 8 or negative 8? Correct. Well, that's correct. But I'm asking you, what's the remainder? The question I'm asking you. Yeah, right. The quotient is what? X plus 6, am I right?
Yes, correct. X is equal to x plus 6.
Okay.
And then the remainder is 8.
Okay. Okay, correct. Okay, be careful about it. Okay, good. Yes. Don't say it's a minus 8, okay? But there are times it can be minus. You're right. Just like I said, it can be negative in the case of algebra. But in this case, it's a positive. So the kids must understand very clearly. If they don't remember it very clearly, quite simple, the sign will be different. If the sign is negative, it will be a positive 8. If the sign is a positive 8, it will be a negative 8. The sign will tell them. That's easy to remember. A negative means what? If a positive 8, I'm short of 8. Oh. Comment. Sorry, what's the comment? Sorry, the example just now, why the remainder is 6 and cannot be 15 plus 9? How to get 15 plus 9? I also don't know. I don't know where to get a 15 plus 9, by the way. How to get 15 plus 9? Is it earlier one? Okay, you don't add together because you must first of all satisfy the 8 first. That's important. Anything extra, by the way, anything extra, we'll take it as a remainder. All right? So that's the reason why you don't add together. Because first of all, you must have the 8. But anything beyond, it must be a negative 8. Anything beyond or below, that is called the remainder. You follow me? Because your answer can be below, can be less than minus 8 or more than minus 8. So that's why, it will give you the remainder whether positive or negative. So therefore, you don't add together as such. I don't know whether I've answered your question. All right? Yeah. Okay. Shall I go on? All right. What's the time now?
Question the B, how you get the remainder is 8?
shouldn't be a negative 8.
Okay. Now somebody says, okay, good question. Should be a negative 8? Anybody want to say negative 8? Yes.
Okay, straight away we use the normal method to divide it.
Now you look at it.
Okay.
If you do it exact, it should be 46, am I right?
Yeah.
It should be 46. Now look. Look at here, what do I get?
54.
I go over. 54 minus what? 46. Is it 8? Am I right? 8?
Yeah.
Over, right? Over.
Extra.
Extra. So I'm going to throw away the extra, am I right? So there's an extra there. Extra.
Right. See the previous slide. Let me check back the previous question.
Sure.
Maybe there's a mistake.
My mistake? Here? This one? Is that a
I
mistake?
think there's a mistake. The minus 6 there should be because what we want is minus 9. Is it true?
Minus 9.
Minus 9.
Oh, sorry.
15, so plus 15 is what they say.
The sign, isn't it? Right? You're right. Thank you very much. Yes, thank you. Yes, I make a mistake. You see that? I also make a mistake here. Mistakes quite common. Plus, right? If I plus, then what happened? Negative. Thank you. I make a mistake here. So yes, this is a negative. Okay, so the box here, this will be what? Plus 15. So this will be a this will be a 6, right? 6.
Negative 9 minus 15.
Am I right?
Negative, if you minus, then it's negative 26.
Thank you very much. Okay.
Negative 24. Negative 24. Negative 24.
Am I right?
No, we went negative 24.
Oh, negative 24. Sorry. Negative 24. Sorry. I made a mistake. Negative 24, not together. It's negative 24. Okay. Okay, just now, okay. I think refer to this one here. Okay, correct. So my friend just now on the online there is correct, okay? My dear friend, I think you're correct. Sorry, I just make a mistake. You're absolutely right.
Those are critical thinking.
Yes.
You just follow.
Good.
Sometimes challenge.
Okay, negative 24. Hello, friend. Are you okay now? Is it negative 24? Right? Sorry. I didn't change the last one. There's a 24. Sorry, this is a negative. 24. Am I right?
Positive 24.
Positive 24. Huh? No, sorry. No, correct. This is positive 24. You're right. Positive 24. Yes.
Negative 9. Minus 9.
What?
How to get minus 9? So use 24.
Minus is correct. Yeah, so correct. So you get 15. 24. Yeah. I think so. Yeah, correct. So that's it. Duplicate there. Okay.
At the end, the 15 plus 24, is it we need to take 15 plus 24 to get the minus 9? Or what?
What's that? Sorry. You will get the minus 9.
No, inside the I think inside the box is negative 24 because we have to add up.
Oh, I see. Okay, negative 4, 24.
At the end, you give remainder positive 24, which is not true.
Wait a minute.
Yeah, this is a weird question.
This is a weird.
Maybe some mistake happened again.
Let me see. There's a mistake here. A negative 9. I have this one to be 15. Negative. Let me see. Do I multiply correctly? $15. It's negative 24, which is correct. Yes, negative 4, which is correct. Negative 15. Negative 24. You subtract negative 9. Minus become plus. So it will be 15. 15 plus 9. 15 plus 9, that's why it's 24. There's a 15 plus 9. That's the reason why. It become 24. So because of that, because of the positive sign here, therefore, because this is the negative sign here. Yes, that's how you reason it out then, okay? It's a matter of reasoning here, basically. All right? It's a matter of reasoning. It's correct. It's correct. Never mind. We look at it first and later on then. Let me go on first in the meantime. We'll come back to it. All right? Let me come back to it, okay? I will explain to you later on then this one. All right? By the way, yes, the one online person is correct. It should be negative 24. Yes. Okay, let me just go on. I.G.C.S.E. Now let's touch on the I.G.C.S.E. Oh, it's okay. I will just got it out here. Sorry. I.G.C.S.E. Yep. Now, I don't know how you teach I.G.C.S.E. Sometimes kids have problem with the I.G.C.S.E. Am I right? Do you have problems there? By the way, I think this is the first year that I.G.C.S.E. was brought down from the A Math to E Math. So the E Math guy, actually they have seen I.G.C.S.E. to be honest with you. Even though you don't use the word I.G.C.S.E., but they've seen it. Why? Because they see the square root before. Okay. Now, but somehow, it seems that they have some difficulty in what? Trying to grasp this concept. What is I.G.C.S.E.? So we had to give them a very structured approach. Right? So, we have to understand how can move the student from a understanding to a procedural fluency. This is the whole idea which I'm talking about. Now, if you were to teach I.G.C.S.E., I'm talking about teaching now, you first refresh the memory of irrational numbers. That's important. Because after they had learned the real line in grade 7, then they learn that numbers can be rational and irrational numbers. Now, of course, I mean, the sad thing about in grade 7 teaching irrational numbers is that we don't say very much about irrational numbers. We simply say that if the number is not rational, it is called irrational numbers. But the poor kids say, what number can be not rational? Like square root 2 is not rational, it's irrational. A pi is, but you see, we only give examples to the kids. But they don't really understand what is the irrational numbers. We're never shown them, we only give a few examples what irrational numbers are, but we never tell them exactly what they are. So I think the best way to talk about irrational numbers is to use decimal representation. Because only decimal numbers can illustrate what number is rational, what number is irrational. The first thing. Because for rational numbers, you look at decimal digits, there will be, after a while, a pattern of repetition. In the case of rational numbers, pattern never exists. Now they begin to understand. They can never find such a pattern. People trying to look for any repeating patterns in pi value. They go to millions of digits there, using a computer, they still can find no pattern. That's why it's irrational. So that's how the first thing is. So, okay, if I see in decimal representation there, if the decimal digits don't repeat after a while, I call that irrational numbers. And this is easier to understand from this point of view. Okay, Yeah, so you can define what is cert. Well, cert actually is irrational numbers. All right. Now, usually what happens is that they understand square, because they learn square root in primary school also, by the way. All right. So they can see how it looks like. So they can punch the calculator there and say, oh, I say, okay, how the thing they would go. No, a cube root also the same thing. Cube root. You know, you find, let's say, 10 cube. Is it irrational? It's irrational. Cube root, no, 10 cube root, you see, it is irrational, by the way. All right? But however, square root of 4, is it irrational? No, this is not irrational. This is a rational number. So they can see that. So that's why, and of course, the famous Pythagoras theorem, they learn irrational numbers, right? Because if you have a right angle triangle, what's that? Square root 2. They learn that. So they can see that, all these are certs. So, okay, so they can to understand that. And of course, you can give them some hands-on activities. I will show them hands-on activities, okay? And to measure certs up to 2 decimal places. They can measure it. Yes, it's a good thing. Measure up to 2 decimal places. See how they would do it then, all right? So that's the whole idea about certs. Now, there are not too many things that they would learn about some of the properties of certs. These are the few things that they would do. Simplify, add, subtract, multiply, divide, and of course, last, learn to rationalize. That's it. So, and these are key problem areas. So to recognize like certs. Fair enough, like light fractions in the primary school. You have light certs. Some certs look alike, but different form, by the way. Error in simplification. Square root 2 plus square root 3 is equal to square root 5. Common mistake, huh? Okay, so these are the kind of thing kids they will make. All right, so that's the whole reason why we had to look at it. And of course, one area is about rationalization mistake. It's quite common. And of course, errors in cert arithmetic is one of the things which is very common. By the way, cert sometimes when they start multiplying all together, it can become a rational number though. Am I right? It can be a rational number. So cert times cert can be rational, can be irrational. So that's why they get very confused. Sometimes become rational, sometimes become irrational. So then when they become rational, when they become irrational. So these are the questions you will have to, this is the problem area when you're teaching certs. Now, I think I will spend a bit more time on rationalization here. Why we do rationalization? The first thing, what's the purpose? Why want to do it? Just because it's good to make life difficult for our poor kids? Why teach them rationalization? Can I do without rationalization? Okay. Okay. Now, of course, we try to what? Eliminate the denominator, right? Make the denominator rational. This whole idea about rationalization. Okay? So, fair enough. Why? It's easy for arithmetic. It's easy to add, subtract, or anything you want to do. That's why I had to make it a rational numbers and a rational denominator. First point. Now, what do you do it? These are only two things. You use the conjugate, you use the what? Difference of 2 squares. That's it. That's all it takes. So I'm sure that now in E-math, they learn conjugates. Am I right? They learn difference of 2 squares. They learned long ago, by the way, when they do the a squared plus b squared. Okay, when they learn a squared minus b squared, so they learn all those things already. So these are things to help them to do rationalization, to remove the cert, so to speak, for the denominator. Another thing, we try to standardize, provide standard form of expression. Easier to make what? Comparison, to add or to subtract or to manipulate the cert fraction, this whole idea. Easier to add, as I say. So that's why you try to standardize it. We try to rationalize in this way. So these are two reasons here. But there are some more. Also the historical reason. I'm talking about the good old days. Good old days are the time when there's no electronic calculator. Okay? And now the kids are very fortunate, they got a calculator there. During my time when I learned, I got no calculator. What do I have? I only have the logbook, or the 4-figure table, you call that. That's the only thing that I have. Okay? So because of that, why? When you rationalize it, it makes the manual calculation easier. That's what they want to do. A lot easier when they do that, okay? But the things that this practice comes until today, we still do it to today. It was an ancient practice because they had no calculator, but now we still do it. And last but not least, today's classroom, we use rationalization what? To reinforce students' manipulation of algebraic expressions involving surds. That's all you want to do. Practice a bit more algebra. Fair enough? They practice how to apply difference of two squares. That's it. So that's the whole idea. That's why we still retain rationalization in doing the surds here. Now, I talk about activities. Can it be fun? Of course, when learning is a bit boring sometimes. You create some fun for the kids, okay? Then I'm going to complete this one here. Complete the Markov table. Can they do that? So they can do it. So it's a fun thing. They can make it into this one, and they can work in groups or whatever. They want to pair them up. They can do it, okay? So this is one of the things that they can do. Calculate the mean and the median for these numbers here. Can they do it? See how they do it. So, okay, show that the mean and the median of these four numbers are equal. That means the mean is equal to the median. Oh, is that so? I mean, they would to figure out. So let them figure out. So these are the kind of a thing, you can create and let them work on it and make it a bit more interesting. Of course, this may not be in the test or an exam or whatsoever there, but at least it reinforces the idea, the concept of surds. Some more. Magic square, you know what's the magic square? Each row, each column or diagonal add up to the same total. All this add together, diagonal, all this must the same total. Can they complete this table here? You see, so these are the kind of, this is called the magic square, by the way. Now, for the primary school, all these are whole numbers. A lot easier. Okay, all these are whole numbers. For secondary school, if you want to do it, for grade 7, you get integers. Play with integers. Primary school had no negative numbers, so they only play whole numbers. But secondary school, you had integers, you play with integers. So when it comes to surds, play with surds. So magic square can be done for many, many things. Okay, so I'll just show you that, you can create an activity using the magic square on surds. Okay, our dear Pythagoras will come in, all right? These triangles have an interesting property in common. Ask them to find out what is the interesting property. Can you find other triangles with this property? You can find out and see what happens. So these are lots of other activities you can create on surds. So once in a while, instead of learning all those simplification, rationalization, all things, throw it at them, let them play with the surds. Make the learning a bit more fun, in other words. At the same time, it also reinforces and strengthens the concept of surds. Now come to the part which, of course, they do all the... Okay, I will come to this one here about equations now. Excuse me. What's the time now? Should I take a short break? Yeah, 11 plus. Shall we take a short break, okay? About a 10 minutes break, we come back. Okay? Yeah, at least we can have a drink or whatever, so you can do that. Okay, we'll come back and then we'll do the equation later. 10 minutes, we'll come back. Hello to online people, we'll take a short break for 10 minutes.
The question is,
Oh, that's not what happened?
I don't know. I cannot get it.
Oh, excuse me. Let me just do it on the board here, it's easier. Where's my marker pen? What's the number? Sorry, you give me the piece of paper.
The question was this.
Yeah, okay, let me see this one. Let me copy it down. It's 24, the negative 24. 24, listen to you get, what do you get? 24 to negative 24.
This one, remainder is positive 24.
Okay, let me see.
I mean negative 24.
Right? So what I do is that what's my divisor? 4x and 3. So this must be 2x. This must be 6x. Am I right? So because of that, I need to make 26. So I will have 26 here. Oh, sorry, 20, not 26. 20x. And so because of that, I will need to have a 5. Am I right? So 5 will get what? 15. But I will get this one here, but to get to the negative 9, I have to add to it what? Negative 24, right? Add to it negative 24. You add to it negative 24, so therefore is the negative 24 is the what? Is the remainder? Yes, you are right. So this is a remainder, correct.
But this is not from our slide. The long division is a the answer will give us a positive 24. This side.
Just now was a negative. No, I changed it already just now, is it? I changed to negative 24 just now. Just see, yeah, I changed to negative 24. The long division
If it's negative, if it's positive, then it's a minus one. It's supposed to be the opposite.
No. Wait a minute. Wait a minute. Correct. Negative 24 is correct, right? So this is a 15. I get a negative 9. So this was a negative 24. Am I right? So you're saying that this must be negative 24. Am I right? I have to add, this will be 24. Negative 24. Yeah, this is a negative 24, correct? Is that what you're saying?
Does the negative 24 means negative 24 remainder? Because if so, then the next question is supposed to be remainder is supposed to be minus 8, not 8. The next one. Yeah, the sign will change. If this is negative 24, then
I
this
must
will be
make it up.
the
I
next-
must
next
make
question.
it up.
Is it like that?
Sorry, just a minute. Let me see. Yeah.
Maybe consistent.
It's correct. It's supposed to be positive 24.
No, minus.
15 or minus 24.
Yeah, correct. Minus 24,
But
right?
You still put this one.
Ah.
Remainder is 6. What's the reason for
Oh, that one is the earlier one.
Earlier, no. We look at he's talking about the earlier one. Let me just see this one.
So the remainder should be minus 34, no?
Yeah, this whatever on the
That's what
table
we-
is the remainder.
You see that? So that's what it is. That's what he's saying.
But Dr. Lai, the next slide
Next
one,
one, yes. Next question also.
the B one,
That is what
because just now our answer was
This one, isn't it?
negative 8. This one. The B, right, our answer was negative 8. The remainder was
yeah, the
negative
remainder
8.
is minus 8. no?
Minus 8.
Because if I use a normal method, right?
Hmm.
X squared.
Yeah, come on.
So we just follow that one. Yeah, just follow that's the remainder.
You question is, if you use the normal method that we have been doing all this, right? Divide by the x plus 9, right? So it's x squared plus 9x. So minus 15 minus 9 is already 6x plus 46, right? So it's actually 6x plus
54.
46 minus 54 is minus 8.
8, correct. Minus 8.
So minus 8 is the remainder. But now you're saying that the 8 is the positive 8 is the remainder.
No, wait. Is it just now we get the negative or the positive 8 just now?
You see a slide.
I can't remember.
I think no slide.
No slide. No, this I had no.
Oh,
No slide. This had no slide. This is
the
exercise.
remainder should be
No. If that were the case, no. Exactly the same. If that were the case, your box there would be like this. I can tell you your box would be like this. What you say is correct. No, what friend one says is correct. Your box would be like this. Your divisor is what? 4x, right? Oh, no, which one? Sorry. Your x is x9. Am I right? This is x here, so it's x. This is 9x. Okay. Then the next one is you want to get 15x. You must add what? You must add 6x. So there'll be 6. So 54. Now I want to get what? 40, right? I must take this over. I must take away what? So that's the remainder. Yeah, right. Yes. Agreed. Yes. So negative. Yeah, correct. So being consistent with the example B just now. Okay. Yeah. Yeah. Okay. Thank you. All this mistake I make anyway, you corrected me. Sometimes we make mistakes. All this little errors here and there. Okay. So at least now you can make consistent with the kids already. All right.
That means we are using the 54 minus.
Yeah, because you have to see. You have to make the what? 46, that's important. How to make 46 out of 54? You must take away, am I right? So that's the remainder, you take away. You see, if you take away, it becomes negative. If not enough, you add on to it, it's positive. You add on to it, it becomes positive already. You add on to it, it's not enough. You follow me? Yeah. If you add on, that means what? That will be a positive sign, am I right? This will be a positive sign. If it's not enough, you can add on to it, then you got no choice but to. Okay, so that's how you would do it. Let us say that if I have this to be 50, for example, okay, that's not enough, right? If 24, no. Let's say if I have this 58, for example, 58, for example, 58, then 58, right? 58. So this will become a what? This will become a 4. So it's not enough, right? So I must add a 4 here. You follow me? I must have a 4 here. So yeah. So, when it's not enough to make up for what I originally have, to add more to it. So that is the bigger. So that's how you do it then. Okay? Fair enough. I can understand all this little confusion here.
Basically, you need the 4 square. But there's a 5th square coming in. The 5th square is extra.
Yeah, so.
This is what I think.
Yeah. Okay, we are the extra, yeah. Correct. First one is 4 square. Yeah. Okay. Oh, by the way, sometimes if you have a cube to do division, it will be longer, this one, okay? Then you will have more columns. You can, actually this one can go to any column. You can divide, your dividend can be a cubic polynomial, can be a quad, degree 4, whatever that is. Just add more columns there, that's it. Yeah. Okay, good. So at least it will clear up this issue here. Yeah. But you think the kids will find it a bit easier to understand using the box to do it?
Yeah, this is for MF students.
Huh? For what?
MF students.
Not for EMF students?
No, there's no division.
Polynomial.
No. What I meant to do division here? No, they don't do division for that.
Only MF.
Oh, MF.
MF they use synthetic. Jump
EMF is the whole quadratic over quadratic. Consider that.
Then they common factor, then cancel common factor.
Oh, common factor, that one is different, that one. But what happened after still got the denominator, then how? Still got the denominator?
No such question.
Oh, no such questions.
That one is MF already.
Wow, so easy. In Singapore, our email have this kind of thing, you know. Okay, never mind. All right, let me go on then to equations. Okay, let's go to the equation there. Sorry, I just want the equation. Okay. Now, equation, you see that everywhere in mathematics. Very common. But the thing is that they serve different purposes. The first thing you have to understand. Equation is not because of that symbol here. We call it equation, but have different meanings. For example, you will see these two. This is an equation, though, by the way. But this equation is what is to represent a mathematical objects. This is a straight line. This is a circle. That's it. Can you solve it? You cannot solve it. It's a mathematical language to describe what a straight line is. What a circle is, that's all it takes. Okay. Of course, we can draw a picture. There's a pictorial representation of a circle or a line. But this is a mathematical representation of a line and a circle. But however, there are equations that can be solved, like this one here. Am I right? You can solve this equation. So equation, it can be solved. So we define a solution as such. So this is a kind of a thing that it can be done. Equation can also be used to define a formula on identities. You define it. Okay? Area is equal to pi r squared, you know, and you know this is a perfect square. So that's basically what. And it's also used in the real applications. They've seen this one here, exponential. Am I right? About the growth rate and all the things there. Okay? And this one here, recognize what that is? That's in the physics, the Ohm's law. Okay, the Ohm's law. So that's basically what, so that you can use equation being used in science, in anywhere, everywhere. So that's the purpose of mathematical equation. It can be used in many, for different purposes. Now, we talk about solving. Now, one of the things important about solving equations, I use the balance tool just to show that it must always be balanced. It cannot be unbalanced, in other words. So what I'm trying to say, that anything you do to one side of the balance, the same thing must be on the other side. Don't forget. I know that over here in Asia, we are so used to moving the terms back and forth to left to right, right to left, blah, 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 so on and so forth, right? Then when you move, don't forget to change sign. Plus become minus, minus become plus, blah, 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 you know. Divide become multiplication, multiplication become division. Kids sometimes, they may forget. They move more happily without changing the sign. So that is why I always advocate that, no, you better do it on both sides. The same operation, that's a lot easier to remember. Okay? And I basically try to simplify to 3 steps. Easy to remember. I know there are many steps, but group it together in 3 steps. First step is to simplify. Second step is to isolate. And last step is to verify. Now, you know the isolate means what? You factor out, you have to isolate the x, the unknown you want to find, right? So that's why you isolate it. But before you do that, you must learn to simplify. It sounds common sense. I must simplify first before I can find the unknown. So kids will remember easier to do that now. Let me just show you what I mean by these 3 steps. Simplify, isolate, verify. Do step 1, simplify the equation means what? Combine like terms on both sides of the equation. Combine them together. Eliminate what? Fractions, decimal, parentheses, everything. You don't want that. Simplify it. Make things a lot easier for you to work with. Isolate means what? You apply inverse operations to get the variable out. Am I right to say that? On one side. Now, on one side, it can be on the left side, right side. It doesn't matter though. Never force the unknown must always on the left side, can it be on the right side? No, I never enforce that. Some kids want to put the unknown on the left side, fine. Some put it on the left side, right side, equally fine. It doesn't really matter. All right, so, then of course, remember that if I do isolate it, I must perform the same operations on both sides. Then they solve for the variables. Now, the last step is this. Kids normally don't want to verify. Is my answer correct? Well, in the process, you make a mistake. All right? So to substitute back the solution into the original equation there to ensure that what is satisfies the equation. All right? And so the whole idea. And check for an extraneous solution. Sometimes you can have something which, extra, which you don't need it, if any. It may not be there, but if any, they're supposed to check it, especially in solving word problems there. Sometimes, to a negative area, you say, oh, I don't want that, I throw away. I only want a positive. So this is a kind of a thing. When you want to take the so-called correct answer from the equation there. Now, I'll show you one simple example. Solve this. This is a simple linear equation. Now, first step is to simplify, right? So what they will do is what? I expand it, simple on the left side. I hate to have the parentheses, so I eliminate what? Parentheses. Now, I always keep my bookkeeping here. I call it bookkeeping. It's not a must, I agreed. In fact, many times we only through all the steps and then we don't bother with all this. I purposely break it down to make very clear what's going on there, okay? Now, for students who are weak, not very sure, I would suggest do some bookkeeping. It's a very much when they try to solve what? Simultaneous equations. Do they do the bookkeeping on the right side? Equation 1 plus equation 2. 2 times equation 1 minus equation 2. And they do bookkeeping. In case I make a mistake, I can refer back and say, when did I make a mistake? Same thing here also. So I just do bookkeeping here. But of course, after a while, they want to so good at it, they can forget about the bookkeeping, yes. I do this only during the learning process. But once they master it, in the exam or test, you don't need to show all this anymore. But just in case they're afraid they may forget even do bookkeeping, it's fine. Examiner will not mark it wrong. Am I right to say that? Yes, you write a few more words here, it's fine. But it wouldn't be marked wrong, by the way. So, all right. So that's basically what it is then. And of course, I'm writing the full words here, but sometimes I've done, taught some students there, they will say, they will add, they will say negative 3x, plus 20x, 20. So that kind of word, it's simple. They don't write a full sentence. It's okay. Never mind. So this is a kind of a thing. Now, first of all, I simplify by eliminating the parentheses. Then I try to isolate. I want to find x, okay? So I move the x to one side. What you do is that, now I say add negative 3x on both sides. So that they will not forget. I won't say, move, 3x to the left-hand side. No, you add to both sides. I only use addition. Add negative 1. I would say minus 1. So add negative 1. Add negative 2. It's easier, Then I simplify it step by step. So I will do it, So finally, I get my answers. Now, how do I know it's correct? Please, last step, verify the solution. You plug it in to see if satisfy the given equation. It's as simple as that. If they follow through this method here, I think they will make less mistakes. I won't say they will make less mistakes. And it's very systematic, these 3 steps. Of course, when they do it, they may not write down step 1, step 2, step 3, like what I'm doing here. But I want these 3 steps to be in their mind. That's important, though. It's not so much that they write down explicitly about the 3 steps, but it's okay, first of all, I must simplify. They must know that one step. Secondly, I must isolate. Then they will do it. Just throughout, from here all the way down, and then they verify. Even without all this additional thing here, it's fine. But I just do this for the sake of during the learning process. That's all I'm doing. Show you another one. Now, this one is I have an algebraic fraction here. So first of all, I must simplify now. As I said, we don't want to see any quotient, so I do eliminate the fraction, right? Now, so what happens is that I will eliminate there. So what I do is I multiply both sides by x minus 1 to eliminate there. That's simple. So I will get to this one here. I simplify and I simplify. So that's basically, this is my first step already. So simplify the equation. Once I get that, then of course isolate. Same thing. You can see that, this part I don't explain. It's very self-explanatory. You can see what happens here. Then last but not least, they verify. It's a very simple 3 steps, 3 major steps, how they would do it through as such. Take them through step by step. For the weaker one, if they want to make sure what they're doing, do some simple bookkeeping to help them understand for equation. I don't need to say so much about all this. It's quite straightforward, to be quite honest. I would never tell them, move 3x to the left, to the right, and all these things there, left, right, up. Because you know why? Something also with our own personal problem. Many people cannot tell left and right. I guarantee you. You tell the kids move from left to right, he will go there, am I right? He does, this is my left, this is my right. He may think along that way, So I never want to use the left and right, I can tell you, you have horror left and right?
No.
No? I thought you have horror left and right.
Remember last time when we learned, move to right, then you change sign. So I never understand why.
Yeah.
But until this method, okay, because it's equal.
It's a balance, it's a balance. It must balance, you see. They must balance it. So that's the whole reason why I said they will have to add, So that's the whole reason why. Okay? I still remember when I'm driving, I said, so I turn left and right. Some people give me the wrong direction, All right? They say, I'm supposed to turn right, they say, turn left, But I think this is left hand, you see, so he will turn left. So that's the whole issue. Words we use is quite important in teaching because we make sure that kids understand what we are saying. So I say, no, you do the same thing on both sides. Both sides, I don't care left, right, do on both sides, then make sure that you won't make any mistakes. Now, if they know this one, it's the same for what? Changing the subject of a formula. It's the same thing. And what they know is the same thing. They just have to what? Do all the reverse, all the operations. That's it. Okay? So the same thing here. I don't need to talk so much about this one here. Now, I'll give you one straight away. Quite simple. I say, make x the subject of the equation. I got a x plus 5y is divided by xy is equal to 2. So, again, I don't want to see the denominator, right? I get rid of it first. So I say multiply both sides. Right? I say multiply by x is on both sides. So I will do it on both sides. And I also do my bookkeeping here. Okay? It's almost like my accounting entry, credit and debit. So I must know all this thing here. And finally, I will get to this stop here and this stop because here, there's no numeric answer. You only have the expression. That's about all right? So, you can do it in this way. Of course, I can also make y the subject of the equation. You can also do the same, whatever that is. So it's quite straightforward. I'm not going to say so much about this thing. Any question, ask me. So once they learn equation, how to solve equation here, then you use this to talk about changing the subject of an equation. It's easier. Link to equation in order to do this one, okay, about changing the subject of a formula. Okay. What's that? Anybody? Yeah. Excuse me. What time is the lunch? 12? 12, huh? Okay. So when they have a square root, what happened? They will have to take away the square root, first of all. Now, before they take away the square root, they must get rid of that, what? Negative 4 first, right? Don't go and square on both sides. They square on both sides, what happened? You get another square root coming up again. Correct or not? So, yes, once they want to get rid of the square root sign, you make sure that one side always only have the square root and nothing else. That's the first thing, okay? So I must get rid of the 4, the negative 4 rather. So add 4 to both sides. Now I have a very clean square root on the right-hand side right away. Okay, then I simplify. Then, of course, I will just square it. I will simplify, square it, so on and so forth there. And once I get my answers, now you can see that my x is on the right-hand side. My answer is on my left-hand side. Is it okay? Okay. Nothing wrong. Okay? Sometimes if you insist, flip over to the other side, you can. Nothing wrong with it also. Because why must I do this extra? I find my x on the right-hand side. Is it good enough? Good enough. In mathematics, if I were to write something like this, Is it okay? Okay. Nothing wrong with it. Equal means what? They're the same on both sides. So the same, why bother to, you bother, it must be on the left side, right side. I don't have to bother with it, by the way.
Same applies to inequalities.
Inequalities, yes.
Sometimes they prefer less.
Yes, okay, same for inequalities, you are right. Same for inequalities. Absolutely right. Same for inequalities. Yes. So please do. Don't try to, force it must write on one side and on that side. No, I would never do that.
For marker, be confused.
Huh?
As a marker, look carefully.
Very carefully, yeah. My God, yeah.
It's like easy to see how when it's
Yeah,
on one
on
side.
the left side is easy.
Okay. Oh, sorry. Yes. What a question?
Can I ask a very, you know the add one,
Which one?
after the simplify,
Ah.
Oh, there's no add one.
yeah, on the left side there's
Should
no
be add
add
one.
one.
Both sides, add one. Both sides.
Shouldn't it be both sides?
Yeah. It's a mistake.
Oh, there's a mistake here. Okay, thank you very much. Just a mistake, eh? You catch my mistake. Good. Let me see, yeah.
Both sides add one.
Both sides add one. Sorry, I missed out the one there. Okay, you see? Sometimes when I'm typing also, I fall asleep. Yeah, I don't pay attention. Okay. Add one to both sides. Thank you. Add one to both sides. Am I right? So that becomes add one to both sides. Am I right to say that? So it become this one here, so I divide it. So it becomes what? 3x minus x. So I will have 1/3. Top one is the answer. Okay, so I will take the top one. Am I right? Yep. Thank you. Yep, thank you. Good. You didn't fall asleep, the rest all fall asleep. Hey, by the way, you as a teacher, it's good to make some mistakes, See if they catch them when they fall asleep, right? You can do that, Serious. Hey, kids, are you awake or you fall asleep, you see? Am I right? Yeah, good. Yes. Yeah. I mean, as a teacher, you can, make it a bit lively for the kids, and then they won't be so tense up. Okay. Thank you. Okay. So much for equation, and this making the subject of an equation. Talk about linear inequalities. Okay, Stephen told me that kids have problem with the linear inequalities in two variables. One variable is easy, it's on a straight line. Am I right? No, it's easier. Two variables, what grade are they learning? Grade 8. So what shall you do? Do you have 3 inequalities? Only 2 usually. These are 3 inequalities. Okay, so you do something like this, am I right? Supposed to shade it and then satisfy the 3 given inequalities. So, how to teach this kind of a thing? No. I think if you do it, I think better do it step by step. I don't blame them if they cannot draw this picture, which is hard, to be honest with you. Yeah, for us, so to do it very carefully. Sometimes we also make mistakes in shading out all those areas there. Now, so we want to introduce, this is a region, by the way. This kind of solution is not a solution, but there are countless solutions here. It's a region of solutions that satisfy inequalities. One type of inequality, unlike equation, yes, many solutions that satisfy the inequality. In the case of equation, usually you only have a handful of solutions. 1, 2, or more, fair enough. But inequalities, guarantee you're talking about, a family of solutions there. Now, these are the 6 steps I would recommend that you can do to teach them. This is about teaching part. First of all, shade some simple region first. Vertical line, horizontal line. And that's it. Very simple when they first learn. So they learn, okay, you shade for me now. They will learn to write the equation and then shade the area which they want. Am I right? You tell me whether on the left side or the right side. Yeah? Okay, so that's the whole idea. Now, that is where I think left-right is important. Okay, unfortunately. So if the kids cannot tell, what you do is that test them first. Raise the right hand. See the right hand, okay? Raise the left hand. See where they raise the hand. If the person who raised the wrong hand, the person has a problem with left and right. Okay? Then what? Then above and below. So these are keywords. Above and below, left and right. So these are the 4 words that I would want to use, okay, to do the shading. So they would learn to draw the line first, so they will shade it up whatsoever there. And same for here too, okay? Yeah, and then they will just learn how to draw the line. These are the boundary. The lines are the boundary. Then they start what? Do the shading. Shade one side first. That's easier. Because they know that if I have a line like this, now, in inequality, they would know they're supposed to draw a dotted line. Fair enough. Now, it's a broken line, not a solid line as such. Now, the only thing that they only to decide whether this one or this one. I call this above the line, this is below the line. Fair enough. Then they will have to decide. Now, how they decide usually? They test points. Right? They take a point out there. Okay? Quite easy because they will know that because from here they will get this point. Let's say if it's a 1, what happened on the line? Then this will become a 3. Am I right? So 1 and this, so this will become a negative 1. Negative 1. This become a what? A negative 1 also. So they take a point a bit further. So they will say negative 1. I take a bit further, maybe 0. So 1, negative 1, 0, and see whether it's here or here. So that's how they will test the point as such. Then they'll shade it. Then it's also good for them to learn incorrect shading. They will learn. Sometimes in learning, it's good to contrast. Learning by contrast. It's a very effective way of learning a concept. In primary school, when they first learn triangle, we always say that a triangle is 3 lines joined together. It has 3 corners. Primary school, they will use the vertices, 3 corners. They know that. 3 lines, 3 corners. So I purposely draw them this one. Triangle? I said, no. I said 3 lines, but 2 corners. So they will begin to understand. This is a contrast. You contrast it. You want to read, you want them to affirm the understanding. It must have 3 straight edges, 3 angles, period. That's called a triangle. I purposely miss out one. They know that it looks like a triangle, but not a triangle. So these are the kind of thing. Teaching by using contrast. Contrast what is not. So what is not? It's incorrect. Hey, this is incorrect. I then okay, I know. So this is correct shading. All right. So so they will begin to shade all those things here. Then you can be a bigger number. Now, sometimes equation may be like this. X and Y can be together. There's another trouble there. Okay, together means what? So that's why should it be this region? So that these are the few areas step by step. Eventually, after that, what happened? 2 inequalities. So I always start with 1 inequality to shade the right region before I will have this one here. Now, once you have this one here, how do you decide which is the correct region? They're all together. You see, 1 line, 2 regions. But 2 lines, 4 regions. 4 regions. So Which one's the correct region? That's the question. Now, what do you teach them? Common area. So, that's right. So, traditionally, you first of all draw the boundary line. Am I right? Let me do a question. Draw the boundary line first. Then you take a point to determine where to shade. All right? So you shade the correct side for each inequality. Where it overlaps, it must be a solution. Am I right to say that? Very typical way of doing it. But I can also do it another way called the elimination method. Same thing, I will also draw the boundary lines, but test the point to determine where it is not to shade, where to not to shade. I cross out all those irrelevant regions. I cross out, I don't want. Anything remain unshaded must be the correct one. You see that? This is another way of looking at it. So if you do it that way, you can see that students may give you answer. This is a traditional way of doing it. Where they overlap, common region. That's where they overlap. This is correct. I eliminate all the wrong one. This must be correct. So there are two ways of doing it. I don't know which way you prefer, or you want to teach a kid two different ways. Some kids are good at elimination. Some kids are good at finding a common area. Whatever it takes. I just show you that these are the possible way of teaching them how to shade the correct area. And of course, there's another one is to what? Point testing method. In other words, what you do is, I'll show you this one. You draw all the lines first. There are 4 regions, right? They test the point on each region. And they circle, all those points are correct. I put a circle there. Those regions where all the points have more circles there, it must be a correct region. They will do that in that way. But this one, they will test all the 4 regions there, okay? Let's say this line here, they'll test, okay, this line, I take 1 point here, 1 point there, I'll shade, which is correct, okay? So they will just draw a circle here or draw a circle here at this point, then take another line to draw it. So which one have more circle area, there must be a correct region. It's called a point testing way of doing it. So there are many ways of doing this kind of inequality. What's the preferred way? Tell me. The same old way, find a common overlapping area. Yeah. But when kids having a problem there, you have to think of another way of teaching them how to handle it. You see, right now I'm talking to you, it's more about pedagogy, about teaching, that's all. All of us know mathematics, we know what to do, but how to deliver to the kids that they can do, that's more important than what we can do. Am I right? Yes. So I think that's the whole issue here about the inequality. I still have some time? Okay, I think about close to it. Problem solving. I will get started first, and then we'll go for lunch. After lunch, we'll come back. I will carry on with problem solving. Problem solving, by the way, is quite important because this is a central focus of math education, like it or not. People never learn mathematics without solving a single problem. That is not mathematics. They must solve some mathematics, okay? And it goes beyond simply finding the right answer. That's not the whole issue about finding the right answer as such. We want the kids to learn what? To understand, to analyze, to apply math concepts to different situations. It can be familiar situations, it can be unfamiliar situations there. Now, the main purpose of problem solving is to develop critical thinking, logical reasoning, and adaptability, adapt to different situations as such. That is the whole purpose of problem solving. And these skills, by the way, is not about skills only for mathematics. These are skills for life. Because they can use it in other areas. Sure, use it in other areas. So this whole idea, okay? And one important thing is what? They must learn to build what? Perseverance. Now, that's a key word I talked about just now earlier on. Learn to build perseverance. Okay? And because if they can master problem solving, they can, prepare them for what? More advanced academic studies in different disciplines, as well as in the professional success in future, put it this way. So learning mathematics, problem solving, is not so much about just for the sake of mathematics. It's actually preparing them for the future in other disciplines also, by the way. You need that skill, not only for science, even for finance, economics, you need mathematics. Now, that is basically our Singapore math curriculum, math framework, curriculum framework. And you can see this pentagon here. Now, these are what we call the components. Right in the middle is what? Problem solving, straight away. But the thing is that in terms of problem solving, you need all the components there. That is important. It's not about problem solving alone, okay? Now, most of the time, we teach this concept. Okay? We will do this, correct. But that is a part. Processes. Competency in abstracting, reasoning, communicating, modeling, all those areas there. And that is where the thinking skills and strategies will come in. These are very procedural, how to skill, how to add, subtract, very basic, how to factorize, divide. So you have to put in this one here, all right? And this one, what do you mean? Metacognition. Help them to learn how to look back what they've learned. It's kind of a reflection. Sometimes when they solve a problem there, can it be done in another way? Reflect on it. Who knows, there could be a more elegant way of solving the same problem. If they can try it, they may find. This is what metacognition, okay? Is to regulate the thought process. And last but not least, attitudes. That's the hardest. How to make them appreciate mathematics. How to make them somehow can have some interest in mathematics. Now that's hard. Okay? Try to motivate, ask them to be more, to have perseverance. This is what the whole idea. Because attitude is important, it will affect their study. Even the topic may not be difficult, but because of negative attitude, they will not learn well. I don't care what subject. It's not only math, it can be in any subject, seriously speaking. And that is where we have to do a lot more in create a positive attitude. Like just now I was told, it's a growth mindset, that kind of a thing. Your mind is not fixated, but your mind can grow, can develop, and learn other skills. So this whole idea about this Singapore math curriculum. And our dear teachers have spent a bit of time over this matter, to be very honest with you. And that's why we all over here, I think for the past few years before the COVID, we had the STEM trail. STEM trail is good. They learn to apply. It's, oh, nice, see, math can be used. Not only science, not only math, but also science. Engineer can do all kinds of things. Math never live alone, Math always comes with many other things, to be honest with you. All right, so that's the whole idea. Now, how do we define a problem? A problem, students need to apply thinking skills and strategies, the first thing. There's no ready-made procedure to be followed through. So they have to think, they find strategies. Students need to explore the solution process. That is a problem. 2x plus x is not a problem. Seriously speaking, am I right? So this is the whole idea. Now, so therefore, in other words, in problem solving, they will learn to what? Discover and develop new solution process. So in other words, when they were to do problem solving, ask them to focus more on the process and not the final answer. That's why when asked me, is the answer correct? I say, who cares? I don't care. The process. I also make mistakes in my answers there. Who cares? I don't care. But the process that makes me think through. That is the whole issue about learning mathematics. I mean, all of you know that in IG, how they mark it, that's called the method marks. It's a process mark that's more important than the answer mark. Am I right? A word problem, let's say for 5 points, answer is only 1 point, 4 points are given to the methods, how you go through the process there. And I can guarantee you, if your answer is all wrong, some answer is correct. You get one point? Thank you. No, 0. Cambridge never give you any point, even the answer is correct, but the whole process is wrong. Sorry, it's still 0. Why? You may have copied from a neighbor. That's it. So bear that in mind. The weightage in the exam is on the process, not just the answer. But you want to ensure the answer is correct, please look back, reflect and see, is it correct? Fair enough. But sometimes due to time is pressing, you have no time, I always advise students there, go back, look at the process, does it make sense? Sometimes in calculation, we make a mistake. Instead of divide, we multiply. Instead of -2 or -3, we make some calculation mistake there. Or answer, instead of 5, put out 0.5. So these are common mistakes people make. Examiner used to be a lot more forgiving for this kind of careless mistake. Yes, you lose some marks there, but you wouldn't lose the whole questions there. It's still there. That is the point, I think, try to impress upon the students. They always say, is the answer correct? I said, who cares? I don't care. Is the process correct? That's what I want to find out. You see? Okay. So I will talk about the Pólya later on then, okay, about the 4 steps. I think, are you familiar with the Pólya? Oh, you're familiar with Pólya? Oh, by the way, there's a book. You can download this book here. How to solve it. It's a free book. It's in the PDF format, by the way. Okay. By the way, George Pólya, he was born in Hungary. He was Hungarian, but later on he became naturalized US citizen. And before he passed away, he saw that the kids in high school having problem in solving math problem. He came up with this book, How to Solve It. And it's a pretty good book, by the way. And most example there, like it or not, is geared more towards the secondary or even higher mathematics. But his method has been adopted and used in the primary math also, by the way. In Singapore, we use a lot of his Pólya's 4 steps, as you can see here. You can download it, you can read it. It's a very good cure for insomnia, I would say that.
After reading one page.
Okay. In a way, it's a kind of heavy. Okay, but it's very good. Okay, yeah, if you don't, I can't read. It keeps me awake. It's, oh, like that, new discovery, right? Okay, so yeah, so. All right, anyway, I think it's about time now for the lunch. We'll take a lunch break, yes. About a few more minutes. Yeah, you can go to the washroom and anything. We come back at what time? 1 o'clock. Okay, I tell you what, today I have to finish no later than 3:30 because I will catch my flight at 6:30. And it's in KLIA2, so I have to rush down to the airport there. So, okay?
They come back at 12:45.
12:45? Can? Okay, good. If I 12:45 come back, if I end early, good. Easy for you to go back earlier, and I can also go to the airport a bit more leisure. Not so. Okay, fine. I will see you later. Okay, let's break for a short while, and then we go down for the lunch. Are they ready? The lunch downstairs? Okay. Okay, now we talk about Pólya's problem-solving framework. Some of you are familiar with Pólya. Some are not familiar. It doesn't matter. So I'm going to go through it again one more time. Those who know it, please bear with me for a short while. Okay. Now he basically come up with these 4 steps, in the problem solving. This is a framework that is given to us. The first is to understand the problem. Then the step 2 is devise a plan. And the third is to carry out the plan. And the last is to look back. It may sound very much like common sense. Of course, when the kids talk about they must go to these 4 steps, yes and no. They do carry out these 4 steps, but they do not carry out to the true spirit of these 4 steps. That's where the whole trouble is. All right. So I had to take you through very briefly what does it mean by these 4 steps, what it takes in each step. This is my question here. Now let's look at it. First of all, before I go into the 4 steps, I talk about problem-solving strategies. Now, these problem strategies also can be found in Pólya's book, the book How to Solve It. It's inside there. these are not the only list of strategies. I said it's a partial list. There are many, many strategies. But these lists of strategies are something it is quite commonly used in primary school, in secondary school. That's why I put them all here then. Okay, but don't worry about all this. I won't go through all this one by one, but I will go through with examples to show you what they mean by these strategies here. Okay, some of these are very simple. Let's solve a simpler problem, use a table, use an equation. By itself, it's quite obvious. But what does it mean? Use an equation, use a table. What does that mean? For what purpose? Now, I think it's best to illustrate through examples. All right, so don't worry about the terminology. By the way, kids never know all this terminology. This is only meant for you. But the whole idea for the kids to learn, not to memorize all these labels here, but to learn in a mindset, they have this understanding what to use, in other words. So labels are not important, but the concept of the strategies are more important than just a label. Am I right? So that's how I want to emphasize. Okay, but don't worry about all this, and then I will show you later on through example. Now, also talk about thinking skills. These are very basic thinking skills. Comparing, organizing, observing are very basic thinking skills. Literally, we have used these thinking skills practically everywhere, not only in math, in our everyday life, in learning other subjects, science or whatever that is, we have all these basic thinking skills, very low level, but these are higher order thinking skills. That's what we want to develop at the end of the day. We want students to learn how to analyze and synthesize. It's a skill. Critical thinking, we heard so much about critical thinking, creative thinking, yes. And these are the skills that can be used in many other areas. And how about the metacognitive skills? How to look back, reflect, what to do with it. Now, lateral thinking is also a kind of thinking skills, except that I don't think we cover that in our education. In everywhere, I've been to many countries, this skill apparently is not commonly used, put it this way. And in exam, they will never have this kind of question. They will require them to use the lateral thinking skills. So I wouldn't emphasize so much on the lateral thinking skills. I'll talk more about those that are commonly used in mathematics. Fair enough? Okay. Now, you ask me a question, is there a difference between thinking skills and problem-solving strategies? Yes, there's a difference. I'll use a picture to show you as an analogy. Thinking skills, what goes in there? It's a mental skill. Can people see it? No, only you know. I can't see your thinking skill. You can't see my thinking skill. What I use, okay? Whereas strategies, it's a tool sets. You can see exactly what the kids are doing. I draw a diagram, you see a diagram. Am I right? I draw a table, you see a table. Just like you see the boxes, you see the boxes there. These are very visual. So these are kind of a strategy I'm talking about. Things that I can see what you are doing. These are things I can't see what you are thinking, in other words. So what can you do? When the kid solves a problem there, how he thinks. You know how he thinks, right? That is the reason why we need a kid to express the thoughts. Tell me how you solve this problem. And now he have to tell you. Either we tell you verbally or he put it in writing. So these are kind of a thing to help, to let the kid tell you what they think in the mind, because you cannot see it. So it's good sometimes, tell me how you solve this problem there. What goes on, you see? You can ask them. What's the first step? What makes you think that this should be the first step? They will tell you, oh, I see this because blah, 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 whatever reason, which they can tell you then. But if you don't ask them, of course, they won't say anything, obviously. So you better ask them. So there's a difference between thinking skills and strategies, all right? Sometimes we call heuristics for problem-solving strategies. This is another term that we use for strategies. Now, I give a very simple example here. Let's look at it. Now, this is a word problem, okay? Pólya's method is very good for word problems right away. All right, now. Anne and Ben each have a saving account. The ratio of Anne's savings to Ben's savings is 7 to 5. they each spend $60 from their savings, then the new ratio of N savings to Ben saving is 3 to 2. Find out how much N now has in her account. Now, when a kid reads through this question, what did it ask you? How much N has in the account? Is it at the beginning or is it at the end? At the end, that's important. Huh? So, oh, I know it's at the end now. Let's apply the 4 steps. Understand the problem. What does that mean, the word understand the problem? Oh, I know, I just read it through. I understand it. You call it understanding? You say, oh, sir, I've read it through already. Does it mean he understands? Not yet. Okay? And of course, for those having word problems, having language problem there, word still. They read through. The understanding is only partial. It's not a complete, okay? Now, what can they do? In mathematics, instead of understand the problem, it means what? You must pick up all the key words, key information. These are the key words. I highlight it. Now you can underline also, by the way, the kids, okay? There are 2 persons, okay? N and Ben, first of all. 2 persons, N and Ben. Talk about the savings. I got a ratio there. How much do they have? Okay? Now this is the initial ratio. Initially, that's what they have. What happened? They spend $60. 60 spend. Okay? Then ratio change, 3 to 2. How much N has at the end? So these are the key information. The other wording are not important, right? You can cross all the other words. So in other words, I pick up, you see, I just pick up very quickly, like a note, I just write a piece there. At first, 7 to 5. Each spends $60. After that, 3 to 2. How about N, how much now? You see that? It's a very brief note I make. Do you see that this one here literally summarizes the whole word problem here? It is. That's all it takes. I don't have to worry about each and every, excuse me, every word there. I pick up all the key information. That's the part. It's good to enforce it when you teach the kids to solve word problems. Pick up all the important information or keywords. Whatever that is, okay? Write down what's okay. Now, after that, devise a plan. What can I do? I look at it. Oh, now I want to use an equation. What do you mean? I want to use a ratio equation. Now, this is secondary, though. In primary, they have no ratio equation. What they do? They have bar model. This question can be solved using bar model, by the way. But since now we're talking about secondary mathematics, I will use a ratio equation, and later on I will use a backward now. These 2 are the strategies. This one, they may not find immediately, but later they find I must work backward. What's the mean? Working backward. Okay, first of all, how to use an equation. Here, I'm talking about a ratio equation here. And so the third part is what? Try to carry out the plan, right? So, after spending now, N has, I said, let's say X, okay, has $3X. Ben has $2X. So that is what it is. Now, I get from this ratio here, am I right? Okay, so 3x to 2x, I will have that. Now, this is the ratio equation. Which one? Plus 60. What am I? From here, I want to go back here. Am I right? This is called work backwards. I work backward now. I'm going from the end, go back to the beginning. So I add 60, that means back to my original amount. This after spending, I got 3x. Whatever the amount is. But at the beginning, I was put back the $60. Once I do that for both N and this Ben, then my ratio will be what? 7 to 5. The first one, at first. Then I solve it. Of course, I will find my X. Once I found X, answer is come out already nicely. Because at the end, N has 3x, right? It's a 3 times 120, so you got 360. So that is how they will do it step by step. You follow me? That's the kind of a strategy that even though they may not memorize all this label here, but in the mind, they should I must use a ratio equation. Oh, I must learn to work backward because I want to go from the last ratio back to the first ratio. You follow me? So that is a kind of a mindset we try to develop, the kids try to develop in their right now. First of all, then, have to look back, by the way. Is it correct or not? Please work it out. To see whether it will satisfy these two ratios, right? Since I found x to be 120, I work it out. Yes, it's satisfied, correct or not? And that's the end of the show. The trouble is the kids don't bother with this one here. Am I right? Usually, the citizen, you answer, oh, teacher, I'm done, period. Right or wrong, I don't care. You decide whether right or wrong. Please ask them, look back. So, it's a very simple illustration of 4 steps. Is it easy? Quite easy. Systematic? Yes. You see, we want to do it systematically. Don't rush into it. Understand first. What's the plan? Then you carry the plan. Kids, many times when they read the question after they finish it, they jump right into here and do this one here. And that's where they get stuck. Sorry, I got a step 2, don't know how to go. Because they never think through very carefully. And so George Pólya gave her these 4 steps, make life easier for them to go about problem solving. Now, what if they get stuck somewhere? By the way, this is not a one-way street. They can go backward. They can go back. So, have I overlooked some of the things at the beginning? Maybe some information I did not notice. So they can go backward and then they come back again. You see? The 4 step is not one way. They can go back and forth. Step 1 to 2, 2 can go back to 1, or 3 can go back to 2, so on and so forth. Please do. So it's very flexible in using Pólya's 4 step. Now, look for this one here. This is from the I.G.C.S.E specimen paper. This is from a core paper, by the way. But I think it's a good problem. It's a good problem here. You talk about the plane flies from London to Colombo in Sri Lanka. The time in London when the plane leaves is 08:20 hours on Saturday. And the time in Colombo when plane arrives is 02:15 hours on Sunday. The flight time is 13 hours and 25 minutes. Find the time difference between London and Colombo. State whether the time in Colombo is ahead or behind the time in London. What grade can handle this one? Grade 7? Can they?
Yes.
Yes. Can they do it very well? Not quite.
Sure.
Not sure.
Depending on the students.
Depending on the students. Some can do, some cannot do, right? Now, let's look at it using the 4 steps. Okay, I'll show you how to do the 4 steps. Now, what's the first step? Understand the problem. Don't rush into it, okay? So, I pick up the keywords. See, I pick all the keywords. That's important. A flight from where? London to Colombo. Leaves at this time, arrive at that time. Different day. Leave on Saturday, arrive on Sunday. Flight time, 13 hours and 25 minutes. Ask you to find what? The time difference between the 2 places. Ask you, is Colombo ahead or behind time? So I pick up all the keywords. So highlight as yellow. I just put it there because I don't want to copy it down, okay? They can highlight. They don't have to copy down what I'm doing. I just show you that they can also highlight. It's the same thing. Or underline, whichever way that it takes. Okay, pick up all the keywords. So when they read the question, ask the kid, don't rush into it. Tell me all the keywords when they teach them. Don't think about solution. I'm not even come to solution yet. Okay, now only that, after that, I will talk about devise a plan. Then I draw a picture. Now draw a diagram. This is my strategy. So I draw a diagram. So I draw a diagram, of course, they will draw from here to here. Okay, so I copy down 13 hours, okay, leave Saturday over here and leave Colombia and then arrive at this time on Sunday. Now, there is one important piece of it. They have to make a decision. Because this time are different, right? You must decide which time to use as a common base. I put it there. I use London as my base time. So that everything is calculated using London time. Can I use Colombo time? Yes. I can pick the base time to be Colombo time. If that's the case, all my calculation will be in Colombo time. So I put that the base time is London. So now based on this, I will start calculating. So in other words, this one no need to change the same as this is London time. But this time I had to change. All right? So that is where I don't know. Sunday, no, 0 to 15 is equivalent to the time in London. Fair enough? No, so that is where I would need to. So this is my strategy. I haven't solved it yet. So to find what's equivalent time, that is in the solution process, which is the third step, carry out the plan. Okay, should I carry out the plan now? No, so I carry out the plan. Now, I start breaking down my picture into what? Time. That's easier. So I can decide to use whole number, that's easier, right? Because I know that, from this time, come to this time here is about what? 12 hours. From 08:20 to 20. This is a military time, by the way, or 24-hour clock. Okay, it's easier for the calculation. So there we can see it's 12 hours. So they start adding up, finally, to this time here then. Am I right? So that's Saturday. How do I know this time? Because I'm using the flight time. Right? About the flight time, it's about 13 hours and 25 minutes. So all this time basically is what? It's the London time. Now I know that this London time must correspond to the Colombo time already. Am I right? So that is a bit different. So I start working it out. Okay? So I start working it out here. So here's the working as you can see then. And after I've done that, I work out what the time difference is what? 4 hours and 30 minutes. Let's look at the time difference. All right? So I can work the time difference there. Then of course I will decide whether or not Colombo time is supposed to be ahead of London time. So this is how they work it out. All right? Now, last step, please look back to see whether that's correct. Whether the count, what do I do here? I'm working out what's the time of departure, which is it correct or not? Because I have my answers there. Is it correct? I work it out. I take away the flight time and see whether I can get back to this number here, because I work out this number here. This is a derived number though. You see that? So that's how the kids are supposed to learn to do it. In case they make a current mistake, never mind. Go back and touch it up. It's all right. It's a straightforward using the 4 steps. Are you clear? Don't worry, I will give you the hand up for this one here, then you will have, you can look at the again and this one. How about this one? Well, this word problem is very simple. Not much words there. Find the sum of period, that's the only words. All these are numbers already here. And these are the certs. Some are certs, some are not certs. This is not a cert, by the way, okay? This is not a cert, but the others are all certs there. How to do it? Now, where to start? Wow, goodness, there's so many terms. How many terms? How many terms are there in this sum? How many terms? 99 terms? 100 terms? 99 terms. You see 99 terms, right? Okay, never mind. Hopefully the kids can, 99 terms. But I can't solve it. How to solve it? So there's one strategy here. Solve a simpler problem. I can't handle such a long sum there. I find a simpler one. I just take the first 3. How about that? I can work it out. Easy. Okay? Oh, I have learned certs. I know how to rationalize it. So I rationalize it. Then I simplify it. Remember, you simplify everything, and I get my answers to be like this. Square root 1 plus square root 4. And I leave in the square root. I don't put in the 1 plus 2. No. Leave in the square root form. It's okay. Because that's not my final answer, by the way. I don't have to make it so nice. It must be 1 plus 2 equal to 3. Please don't do that. Leave it nicely. But because I leave it nicely, I look at it, I learn to what? Observe and look for a pattern. I observe it and look for a pattern. What pattern can I see? I only have 3 terms. And among the 3 terms there, these 2, this square root 1 comes from here, am I right?
Yes.
The square root 4, comes to the last one here. I see there's a pattern though. If I don't believe it, I can add one more there and see, and another one there, am I right? To see whether it will go to square root 1 plus square root 5, for example. If they see the pattern, say, now I see the pattern. I know how to do it. So I can see the pattern, It must be the what? The first one and the last one here I put together happily. Now I can simplify, I get my answers, in other words. You see, the strategy is solve a simpler problem, look for a pattern. These are the strategies I'm talking about. That's how a kid's supposed to learn to do it in this manner. Okay? And simple, I don't want to simplify so that I can see the pattern. Simplify, you lose the pattern already. Easy? Easy. Okay, you can try with the kids and see whether they can do it. But the 4 steps really help them to understand and how to solve a problem there. You tell me how to do this one using the 4 steps. Now, you try and see what happens. Tell me. You can use your phone if you want to. The calculator is there in the phone. The picture captured practically the whole question there, am I right? All the words are being summarized in the picture. So the picture actually, given the understanding of the first step, understand the problem. Basically, the picture tells everything about the first step, about the so-called about the problem here, okay? So the question is that devise a plan. What plan can you devise? What should they use? Now, don't talk about what should they use? This is my question. What strategies can they use? Come on, tell me, what strategy do they use? Okay, good. Good. Okay, good. So you have learned sine, cosine, tangent. Am I right?
Yeah.
Where can I use my trigo? You look at it. I think I can only know how to find this angle. Am I right?
Yes,
Yeah.
yes.
That's all very simple. I can use tangent.
Tangent, yeah.
Okay, good. Oh, I happily found this angle. Who will tell me what's this angle here?
5.99, I think.
About 6, right?
Yes.
Okay, let's 6 degrees. Okay, good. 6 degrees. Hey, what shall I do?
Then compare with the bigger triangle.
Bigger triangle. Okay, tell me.
Then you get the angle.
This one, isn't it?
Yes.
That one. Yeah.
Yeah. This angle here, isn't it?
Yeah.
This is a complementary angle.
It's 4.
Okay, so I know this angle. Good enough.
And then you get the other side.
Look at the angle, okay?
Yeah.
So I know this angle, I know this angle. Okay, now look, okay? Now, I'm talking about about the thought process, your strategy. I found all these angles. Good. Can I solve it still?
Need to know the Pythagoras.
Oh, dear Pythagoras, I need the help of Pythagoras, right? Thank you very much. Help me find this line.
Yes.
Okay. So we call upon Pythagoras and we found this line. What comes next?
Cosine rule.
Sine rule.
Sine rule. Sine rule, right? But if the kid have not learned sine rule, then how? Cancel?
Split the 68.
Split it. You're right, split it. Because In grade 8, they learn right angle triangle yet. Sine rule consider is a bit later, right? Grade what? Grade 8, isn't it a bit later? Huh? So therefore, they can still do it. Yeah, right, they can split it. So I think I have the solution to show you. Yes, right, that's one way. Where is my split? Am I right?
Yes.
There's a split, they can do that. Or once they do that, now that is what we want. Introduce auxiliary element. That's one strategy. Very common in geometry. Things are not there, you introduce it. Where is another circle, another square, rectangle, or a line, you can add to it. And this strategy is called introduce auxiliary elements. Now, this term is not meant for students, but you know what to do. I'm going to add something more to the question there before I can solve it. It's a very common practice in solving geometry problem, I can assure you. Okay, so once I do that, then I must know this angle, right? But that's quite easy because I know that this angle and this angle are alternate angles. So therefore, I can find my alpha is what, 68 minus 6 is 62 degrees, right? And so therefore, again, my dear trigo will come and help me to find this height. Since I know this already, right? This is 14. So I work it out. Then I have this height here, but that's the height of the whole building. I might add up the height of this person here. So add together, and that's the total height. So that's how they do it. Apply one strategy is what? Is to introduce auxiliary elements. That's how they will do it. Now, this now without the sign rule whatsoever. Of course, sign rule will definitely help. Yes, I agree with you. If they learn it, by all means, they can straight use it as such. Okay, so this is a very straightforward kind of a question. How about this one? Now, I'm not going to solve it yet. What strategy that comes to the mind of the students? Well, look at this one first. Okay, you have a rectangle, ABCD. You are given an angle BFC, 70 degrees. BFC is this angle here, 70 degrees. You are given this angle EBC, 2x, and DBE, this one is x. And then BEC, the angle is y. Find the values of x and y. When they read this question, look at the picture. Pictures given them already. My question is that what problem strategies can they apply? I'm not talking about solving it yet, but strategy, what can they do? Actually, there are hints given in this question there already. I purposely use the letter x and y. Kids learn x and y in algebra.
Yep.
I must use algebra. Oh, good. But how do you find x and y in algebra? I must have equations. So straight away, I must use an equation to solve it, number one. So that's a strategy, use equations. But since there are two unknowns, x and y, I must use what? Two equations in order to solve it, am I right?
Yes.
Yeah. See, that is what I want to see in the kid. They can think about all this even before they try to solve it, in other words. Before they even know what are the two equations, I think, oh, I see I must use two equations because there's two unknown x and y. If they can crack through this mindset, half the problem is done. So all they're going to do now, third part, carry out the plan, right, is to what? Write down the two equations and try to solve it. Now, what can they do? Well, that's quite easy. Who can tell me the first equation, the easy one?
2x plus y equals to 9.
Ah, then you know that. Okay, teacher, I know. 2x plus y is equals to 90. Good. Now the second one, hard to find. The second one, don't know where to find. Huh? But one thing they must recognize, 2x plus y is equal to 90, which is very easy, obvious. But one thing they must learn to observe, hey, I have not used this info here, I have not used it yet. Somehow the question must use this 70 degrees. Am I right? Somewhere along the line, I must use it. And how to use it? So I must find a second equation. Well, to use this one, what can I do? I can see that this angle plus this angle is 70. Am I right?
Correct.
Correct. But what is this angle? I don't know. I wish I know something about this angle here. You see, that is the way to look at it, look for the second equation. Okay, so I must know that I must have my angle y plus whatever the unknown angle is equal to 70. Am I right? Okay, I cannot put the question mark is here. But how to find this angle? Now, I got one more piece of information I have not used. What information I have not used?
ABCD is a rectangle.
That's right.
So at the diagonal,
I had not used that, right? So I know that this angle and this angle are what?
45.
Equal. 45? No, 45. Equal.
Yeah, equal. Yes, equal.
Oh, equal. Oh, very good. Huh? Equal. Huh? So equal, I know that this plus this is what? 90. So in other words, I know that this little unknown plus what? 3x is 90. Am I right? Therefore I know my question mark already, which is what? 90 minus 3x. I could put it there. Am I right? So I put it there. So now my equation becomes what? Y plus what? 90 minus 3x is equals to 70. Oh, I got two equations very, very nicely, right? Just solve it. You see that? So in other words, the kids must learn, first of all, when I see x and y in this question, I need two equations. Because I can use algebra here already. The next thing, they want to make sure that I must use all the assumptions given to me. First of all, the angle here, 70 degrees, is given to me, number one, which I used already over here just now. But one thing, what she mentioned is that there's still a rectangle there. A rectangle got two diagonals. So that is what the mindset is all about. So I don't have to solve it. So once they can do this one, I'm sure that they can solve problem quite easily. At worst, they may make some simple calculation error. That's about all. Other than that, it's fine. But even if they make some calculation error, don't forget the fourth step, what? Look back. If they look back, they find the error, then they can correct it. You follow me? So that is a way to use the 4 steps in Pólya's method. Come on, any question you want to ask me? Is it easy to teach the kids? Yes or no? Come on, you all pass to me. What do you think? The question now is not whether you can solve it. I'm sure you all can solve it. But how do you want to get it down to the kids' level? That they learn, understand how to handle it. This is the crux of the problem for the teachers. And to it, it's a challenge. You see, I always tell the teachers one thing. All the things that we do here, we all can solve it very easily. Even can find shortcut here and there and do all the things there. But in teaching the kids, it's a bit different. They would never be able to see the way we see things. You must admit that, number one. What we see through our own eyes, the kid may not see the same way. So as a teacher, what you can do? We must learn to see through the eyes of the students. Their eyes, not your eye. And that is hard, and that's the challenge. We have to lower ourselves to see what they see. And for that very matter, how do you do it? You ask them questions. How do you see? Tell me what you see in this question here. Once they tell you, then you see what they see. You see where they get stuck. That is the whole idea. And one thing is to call the kid, don't try to rush into finding the answer. That is the last thing you need to worry. It's a whole strategy. It's just now because of time constraint, I simply verbalize how we look at it. Am I right? This is just the strategy. I have not solved it. I still don't know what's X and Y yet, but I just verbalize my thought process. So you have the kids guide them through, let them to be able to tell you their thought process before they even write down and solve those equations to find the values of x and y. You follow me? So that is the way of dealing with the students. So, okay, so this is not so much of whether or not we can solve it, but whether they understand how to go about doing it. Now, another thing is about reasoning skill. You see, most of the math problems involve calculation. Like just now, so far, talk about all the calculations, so add, subtract, multiply, and divide, and all kinds of things. Solving equation, factorization, and all the things there. But the whole idea is to develop students' reasoning skills. Okay? There are math problems that students need to find answers purely by reasoning. That means no calculation, purely by reasoning. That's such a problem there, okay? So in other words, I say that to handle these type of problems, students must have a what? A good understanding of the concepts and also some key properties. First thing, that's important grounding they have to have. Good understanding of the concept and the properties, and then learn to do logical reasoning. So the key word is good understanding of concepts and be able to do logical reasoning. These are types of questions with no numbers, purely by reasoning. Like what? This is a question taken from Singapore O-Level, paper 1 in year 2023. Look at this question here. ABC is a triangle. D is a point on AC such that it is equidistant from A, B, and C. Explain why angle ABC is a right angle. No number. There's a picture, and that's it. Explain only, not the color. Explain why. They told you, this is a right angle. They told you already. Why, you tell me? Give me a reason. That's paper 1, our Singapore O-Level. So what do you expect to do? Write out the reason. Am I right? So therefore, the whole idea about this question is, look, can they reason out without any numbers here? Why this is a right angle? Nothing to calculate. Do you see the reason why it's right angle? Anybody? Now, obviously, there must be they give us a point D, right? They say, such that so it's equidistant from the 3 points there. So when they see that, what do they see? What do they see? I told you that, in other words, this length, okay, in other words, you have this picture here, right? You have something like that. They say that, okay, it's equidistance, right? A, no, this is B, sorry, this is B. B, A, C, D. Am I right? So that's what is given. So what do they see? Isosceles triangle. How many? 2 triangles. That's right. And once they see that, and one thing, that's why they had no property. What's the properties of isosceles triangle? 2 sides are equal, 2 opposite angles are equal. Am I right? So these angles are equal, right? This angle is equal to this angle. This angle. Am I right? Once they see this picture here, can they see now why the angle ABC is a right angle triangle? Straight away it falls out nicely. Do you see it? So now once they see that, that's how they would write. This is only a typical answer. They may write differently, but that's the typical answer. Just a few lines, and that's it. So you see, this question purely by reasoning. Am I right? There's no calculation. So the concept understanding must be very good before they can do it. You want to try it with your students, see whether they can handle this kind of a question. What do you think, friend? You think the kids can do it here? Can try them?
Try.
It's serious, you know. But all these things are within, they have learned already, fair enough. Nothing new, to be honest. But they can try and see how to handle it as such. I'll give you another one. These are the problems to develop reasoning skill. I put it that, this is my heading here. Now, next one. You ready? Are there any numbers for calculation? Not really, yeah. They only have a picture there, huh? About the two drums that represents, about the sales. It's sales triple in 10 years. It's from year 210 to year 220 years. Okay? And they told you that the dimensions of these two is what? It's 3 times, right? It's 3 times the dimensions of these dimensions here. Fine. But the thing is that they tell you one thing. Is that the chart is misleading. It's not right. How can the sales triple in 10 years' time? It's misleading. So explain what it actually implies in the company's sales of the tin food. What does it actually imply? So what can the kids do? Hey, sorry, there's no calculation. Give me the height, the diameter, the radius of the 2 cylinders. How can I figure it out? Only about the dimensions 3 times, that's all it says. How to figure it out? So in other words, since there's no calculation, you can only reason things out. Again, reasoning. Now, one thing about dimension, if you do 3 times is a ratio, am I right? That means the dimension is what? 1 to 3. Fair enough?
Yes.
Good. So, here you talk about the length, right? Or dimension of the length. Okay? This is small. This is a small cylinder. And this is a big cylinder, am I right? Big and small. It's a ratio, am I right? And that's what it's given you. And so, hey, by the way, this is misleading. Why? Because if you go from length to area, what happened to the ratio? You square it. And then you go to where?
Volume.
Volume. And what you do? You cube it. So in other words, if you look at the volume, that means what? It's 27 times of the sales in 2010. Am I right to say that? That is what the kids are supposed to learn to reason it out, using this kind of a reasoning skill, from length to volume, in other words. So therefore, if they were to write out something like this, since the dimension of 2020 is 3 times the dimension of 2010, the volume of 2020 must be 27 times the volume of 2010. That means the sales in 2020 is 27 times the sales in 2010. That is purely by reasoning, no calculation. That is the second question, also the same paper in 2023. So that year, in 2023, there got such 2 reasoning skill problems in our paper 1. And it's a good skill. It shows one thing. They must have good, solid understanding of the concept of this kind of relationship. Am I right? That's the whole idea. What do you think? What's your comment? Is it too hard for the students here? Is it too hard for the students?
Yes, because they don't think critically.
They don't know how to reason, eh? Okay, about time to have them to do reasoning, okay? About time. They must start somewhere. Huh? It's better to be late than never. Late, never mind. Get a start. Okay, get started. Okay? Hopefully the online people can hear me. Okay? Don't be afraid. You can start now. Even if it's late, doesn't matter. And this kind of a reasoning skill, which I think we need to develop in our kids. Polygons, our dear polygons. These are the regular polygons. Okay, you have a sequence of regular polygons. A different number of sides is here. You have all this, number of sides here, okay? Now, you know what's a diagonal, right? Diagonal is the one that you join. These are diagonal, right? So that you can see the number of diagonals. Triangle, of course, have no diagonals. Fair enough, so it's 0. So the square have two diagonals. And then the pentagon has what? 5, you can draw 5, that's easy. And of course this one is 9, getting more and more diagonals, fair enough. Now the question is that, can you find the number of diagonals of a regular n-sided polygon? Can you reason it out? How do kids learn to reason it out? Just read by reasoning.
Look at the pattern.
Look at the pattern, good. The pattern, okay, good. Look at the pattern, good. That's very good. Look at the pattern, good. Now, I want to hear from you people. What pattern, by the way? Don't get a label. Tell me exactly what pattern that you can look for. That's a good question. Okay, that is a good thing to start with. Yes, right? Okay, so imagine, let's play the role. Okay, I'm your teacher here. So, okay, you say, look for a pattern. Say, good. Okay, look for a pattern. Let's look for a pattern. But what pattern?
Difference.
What pattern?
Difference of the
Number of
number of diagonals.
Number of diagonals. Okay. What is a diagonal? If this point here, join this point, is this a diagonal? No. So, is this a diagonal?
Yes.
So, in other words, a point can join to any other line, any line forming a diagonal, but cannot be the two neighboring points. Am I right to say that? If you take this point here, these two are my neighbors, I have no diagonal. Take the square, easy. These two are my neighbors, no diagonal, only this is opposite point, right? So I have one diagonal here. So same, this one, I don't have it. How about this guy? Same. I can have diagonal for my two neighboring points here, but for the others, I can have it. Oh, what does that tell you? I want to use diagonal to join to my points, but I cannot include my two diagonals. No, I cannot include my two neighboring points, sorry. What does that tell you? How many diagonals can you draw? Now you think about that. If I got n-sided polygon, now let's see. Okay, 1 point. Okay, n-sided, I don't know. Okay, many points, right? I don't know what they are, very big, huh? Okay, all this thing. I can join to many other points, right? I can join here, I can join there, right? I only cannot join to the two neighboring points. They cannot be the diagonals. So how many points can this guy join? N minus 2. Hey, good. From each point, I can join n minus 2. I can draw n minus 2 diagonals, right? Good. So, 1 point, I can have what? N minus 2 diagonals. Am I right? You say that very well. Can the kids see it? They can see it now. If they can see it, Go back to a simpler problem, right? Give them a pentagon, whatever that is, a simpler one first. Then you can draw it. Oh, yeah, I can see. Always must say less 2, always less 2. Fair enough. Of course, now because you're teachers, I can go straight away, go into this one, okay? But the answer to the polygon got how many points? N points. So N points, how many diagonals can I draw? Since 1 point is that many, N points of N times, am I right? N times it, good. So every point I can draw, join to all the. I say, wait, teacher, it's not quite right. Some point get duplicated. If you take this point, this is one diagonal, right? But this point also join here, right? So it's a double counting. Am I right? So this is a double count. Huh? So not quite correct. Yeah, correct. End point I can draw so many there, but it's a double count. What should I do? I halve it. That's my formula. You see how you can reason things out. Take the kids through. From very simple. How many diagonals can they draw from a vertex or from a point, whatever that is? You can reason it out. But one thing, this purely by reasoning. You say, but teacher, how to calculate correctly? Can you calculate? Yes. How to calculate this? If I want to calculate exactly this little formula here, now this formula here, can I derive this formula mathematically? Okay, how to do it? What comes to the mind? You look at here, I got a number of sides. I got a number of diagonals. You say, look like it is a sequence. So they have learned, what grade do they learn sequence? 9.
8, but then this one quadratic sequence 9.
Yeah, okay, 9. Actually, in primary school, they also learn sequence, but simple sequence, not so complicated. So they learn sequence. So they learn sequence. Okay, now let's see that you will use sequence. The trouble is, this starts with 3, n starts with 3. And then here, the m is 0, and then 2. Okay, so where should you start? It's hard to start from here, but I can start from here. Because the whole idea is to find the diagonals. So I must find here. And if you look at these numbers, 0, 2, 5, 9, so on and so forth, what sequence do you see? Come and tell me a name for it. There's a name for this sequence. 0, 2, what? 5, 9. What sequence do you see? From here to here? Plus 2, very good, plus 2. From here to here?
Plus 3.
Oh, happily good. Here to here, plus?
4.
And you can guess next one will be what? Plus? 5, which is 14, right? So next should be 14. Okay, never mind, just stop here. What sequence is this? Quadratic. Oh, thank God, quadratic. Okay, good. Then I know quadratic must have which form? If I use the m to be my variable, it must have a form what? Am I right? Well, this is my m term. And you know what's a quadratic? The next one, this is called the first difference, am I right? We call it the first difference. Then you have the second difference. Am I right? Because the second difference is a lot easier because from here to here is what? Plus 1, plus 1, plus 1, am I right? And that is what you call, it's a linear. You see that in a quadratic, this is quadratic, but this is linear. Am I right to say that? So a quadratic function basically is a quadratic form plus a linear form. Together, you get a quadratic function as such. So that is how, they will begin to see that. And from there, I must work out the A, B, and C. Okay? Because of time factor, I show you the whole solution. You can take a picture of this one here. okay, if you want to, because I don't think this is, I already do up, let me see, where is it now? All right, you have this number of diagonals. I use this UM to stand for the term, okay? So the first difference is what? Plus 2, plus 3, plus 4, plus 5. This is quadratic. So therefore, the second difference in this one here, and what I will do is what? I'm supposed to find this term here, correct? And straight away, I use the table now. One thing about quadratic, if you use them, please use the table. Why? Help to organize. A lot more organized, to use it, a lot easier to see. So what I would do is I would draw this picture here, of a table rather. My M starts with 1, 2, 3, 4, 5, fair enough. And now my term is what? From 0, 1, 2, 1, 2, 5, 9, 14, so on and so forth. Fair enough. Half M squared. Where do I get a half? That means I know my A is half though. Where the half comes from? It's a half the second difference. Give me the A. Two A in a quadratic sequence is always the second difference for that linear sequence, always. 2A is always the difference. So in order to find the A, you halve the second difference, you get the A. Since it's a 1, you halve it, you get a half. So this is a shortcut to find your A. You can easily show the student why it is 2A, by the way. I have no time to show you now. You can show it quite easily. But once you can do it this way, that means what? This is done only to find these two, right? So I will take the what? I will take the subtraction. Am I right to say that? My n term minus this one will give me this linear term. Am I right? You can see that, and I will do it this way. So once I do it this way, can you see that? This is linear. Am I right? This is a starting term. This is a difference for this one here. Always what? N minus 1. I get it up to here. So that is my nth term, number of what? Diagonals, okay? In the M diagram there. But sorry, I want my n. I haven't come to my n yet, you know. This is M is on diagonal, right? The n is about the number of sides, you know, of the polygon, right? How to go from the diagonals back to my, related back to my so-called, related back, you want to take a shot there if you want to, come on, just take a shot if you want a phone. Yeah. Okay, I have this one here. Now, I must go back to my M, right? Now, look at M again. This is my N, right? So, this is a non-diagonal. I can see that. How to relate my M to my M, by the way? I what? Use an equation. This is my equation. I transform. Transformation of an equation to an equation. I transform my M, let M to be equal to what? N minus 2, because I know that my N must start from 3, number of sides. And then after that, I plug it into the equation here. I now have the N term, replace it exactly as what we have at the beginning. So that is the actual derivation of the formula of the number of diagonals of a regular polygon. But my focus is more on the reasoning skill. I don't think in the exam it's fair to ask them to do this one. It's very time consuming. Usually the quadratic sequence is very simple for the kids. But the table, just I'll show you the one, is very useful, by the way. It will shortcut a lot of methods. I know what happened many a time when I teach them. You see 3 unknown, A, B, C, 3 equations. solve them simultaneously. Oh God, how to solve three equations simultaneously? Can be done, of course. But I shortcut it. I don't need to go through that process. All you're going to do is to show them why you can get the A from the difference of the linear part. That's right. The second difference. And that's the only thing you need to show. It's very simple. It's only about 2 or 3 lines, and you should show it all already. Is it still with me or still sleepy? I'll take a short break, about 10 minutes.
-3 and then -2 is supposed to be the same.
Is it -3? -3 lah. So -3 or -2? Oh, -3, sorry, -3. Sorry, I make a mistake. Sorry, -3. You know why -3? Include itself. Sorry, I forgot about them itself. The 2 neighbors plus itself, 3 points, sorry. Yes, so okay, -3. Yeah. So that is the way we can look at it. This is a very rigorous way to do it, to be honest with you. This is mathematics, yes. But that was a reasoning skill. Now I would prefer kids learn how to reason it out. This one you can show them slowly if you want to teach them, fine, you know. And because it's good to show them some of the strategy, when to use the equation, when to use the table, so on and so forth. These are the things that it can be done. Okay, so I think we take a short break, at least, let's take a short break before you come back, 10 minutes. Then we'll come back, we'll try to wrap up the whole thing for you people. Yeah, let me see the time now. Oh, I think I should end a bit earlier, no problem. So you think reasoning skill is good? What do you think, our gentlemen?
Sometimes so hard. This one.
Huh?
For students, it's hard.
Hard one, huh? Yes. But this is mathematics, by the way.
Okay.
But reasoning skill is a bit different, am I right? Okay, reasoning skill in a way is a very intuitive. It's based on their own observation. See, the kid must be very observant of what they see, about the pattern and all the things there. So develop that kind of observation is good for them to do mathematics. Even in science, by the way, science focuses on observation. This is one important skill in doing the science. In physics, in chemistry, in biology, all scientists learn to observe, by the way, all the minute details. If they are not observant, there will be no new discovery. Am I right to say that? Serious. Same for mathematics. Learn the observance. That skill can be used in science at the end of the day. See, come on, take a short break. Okay, you can go to the washroom, wherever that is. We'll come back. All right.
Reasoning skill, you don't need to memorize the formula.
Don't need.
This one you understand already.
Yes, you're right. Correct. Many a time I learn equation formula, not by derivation. You know why? Because even if I can derive it, after a while I may forget. But it's quite common, we all forget. But I will do what? I use reasoning skill. I use a picture to learn. I can represent an equation with a picture. Okay? So that's the whole idea. Can you have a picture for y sine squared x plus cosine squared x is equal to 1, the Pythagorean identity? Why? Can you see how it looks like? You know the sine curve? You know the cosine curve, right? They are done to draw the sine curve, the cosine, all the wave there. But why when you square these two, sine and cosine, you add it up, it's 1. Why? What does that mean? You think about that very carefully. So that is the whole thing. Okay? You think about that. So why so? So never mind, we'll take a short break and then we'll sit down here, take a break from all the math for a while.
m equal n minus 2. Why?
Oh, that one.
Look at
Oh, okay, never mind. I'll show you that one.
the next slide.
The one.
The next slide.
No.
One more slide. This one, the m equal n minus 2. Is it the same again? Or
Yeah,
is it
same.
different? This one, n minus 2.
I do a transformation. I replace my m by n. But I cannot replace it like that. I must find something how they are related to each other, right? Number one. Remember, my n starts from 3. M starts from 1. I cannot say n minus 3. It becomes 0. So it must start with n minus 2 so that I can get a 1. You follow me? Because my m starts from 1. Don't forget, I keep saying that. So it's a 1, you know. So it will start from 1. So n must be 3. So when n is 1, this is 3, right? When n is 2, then you get 4. So that you can see that.
Yeah, but does it relate to the top information?
Yeah, in a way it is true. Because my m here, this m is a 1. No, this m is the number of terms, you know. It's a number of terms. M is the number of terms. M is the number, not the UM, you know. Don't forget that. It's the number of terms start from 1, 2, 3, 4, 5. You follow me? It's my counting. My n start from 3, 4, 5, 6. Am I right? So I have to change the variable. It's a change of variable, not change the m term. By the way, don't forget. So I use this one, the partner, to change that equation into the n equation rather than the m equation. That's what I'm doing. Clear? Yeah. Yeah. How do you find teaching them the quadratic sequence? Is it hard?
Okay lah. They have to get used to it.
Get used to it. Yeah, but it's good to tell them about the first difference, the second difference, and tell them where to look for the linear sequence. That's important. They must see the linear sequence. It's only 2. If it's a cubic, then of course it will be a lot more. So, but this is a linear, so it's quite quadratic, quite straightforward. Okay. All right, since I'm here, let me carry on, if you don't mind. Shall I carry on?
Yes.
This is another one.
No, right?
Is there some spot on the path that he occupied precisely at the same time on both days? On that day, he stepped on the same spot exactly at the same time. If it is 10 a.m., say for 10 a.m. If it's 11 or whatever that is, any time, is it such a spot? Think about it, but same path. He came down also at the same time. You see that he goes there at 10, am I right, in the morning, then to the top at night, 8 p.m. He stayed overnight. Next day, after he finishes his meditation, he will come down. Again, he will leave the top at 10 a.m. and reach back to the bottom there, 8 p.m. Same path, there's only one path to go up to the mountain there. No two paths. Yes or no? How many say yes, how many say no? There's no calculation, all right? You cannot calculate anything. I never show you how the path is. What's the equation on the path? Sorry, there's no equation here. This is about the, you know. By the way, I also don't tell you whether he walks faster or slower, right? He can be, oh, wow, and then he rests for a while, and whatever that is, right? So the speed can be different, you know. Yet there could be a time where he can step on the same spot, the same time for both days. Is there such a place? Actually, if people who have taken the first year calculus in the university, this answer can be answered yes, mathematically. Okay, but I won't go to that because that's beyond the O level, that's beyond the A level, so I won't go into that, by the way. There's a one calculus theorem that assures me that it can happen. But why? I had not learned first year university calculus yet. How can I know whether there's such a point? Can I reason it out? The answer is yes. The secondary kids can reason it out. They don't need the high level mathematics. Can they see a picture of it? You think about that. Assuming if you can draw a graph. Draw a graph. Okay? I try to reason it out, okay? See, this one cannot be solved, by the way. I draw a graph. Let's say this is about height of the mountain. And this is the top, right? This is the bottom. This is at the bottom. Bottom is here. This is the top. This is the time, fair enough. You start at what time? 10, isn't it? Then, 8 p.m. Now, if there's a path, the path can be represented by a graph, am I right? Because as you go, because the height, it will go higher and higher. I don't know how the graph looks like, because I don't know how fast, how slow it is, you know. This is a what? This is a distance time graph, by the way. So I draw the time graph, I don't know how it looks like, never mind, I just anyhow draw it, right? So I don't know how he goes. Pop! You go up there to the top, right? And that's it, so it will match here. Fair enough? So, you want to. The next day, he starts coming down. Same path. He starts from here, right? You come all the way down. You come all the way down. Hey, there's a point. Same height, same time. Am I right? This graph is different from this graph. Because I say go down could be a different speed, different, slower, faster, whatever. Could be different graph. But no matter which graph that you draw, somehow the two graphs must intersect at some point. So there must be a time, a common time, time t, whatever that is, where he reaches the same height. Is it easy to understand? Use a distance time graph just to reason it out. Of course, I don't know what time is this because we don't know the equation of the two lines. It doesn't matter. I'm talking about reasoning skill. Now, that is what secondary kids can do without higher mathematics. What say you? Okay. Sounds very simple, am I right? You don't need very high power mathematics, simple mathematics can use a distance time graph, just do it out as such. Try in the kids to see what happens. That's all about reasoning, you see. I spend some time train the reasoning skill. That's all it takes. Okay? Want to take a photo? Can take a photo for this if you want to. But anyway, it will be in the handout also. Now, no, you don't take it, sorry? Oh, I'll take this one here, okay. Now, this is the last part here, pedagogy. Okay, these are all the things, the skills, you know, okay, I'm supposed to help the kids, but how to teach them? That's my question now. So it's about delivering now. Not so much how much you know, but how to deliver to our dear kids anyway. So how to teach problem solving. First of all, I think that problem solving, I said, should not be carried out haphazardly. structured approach, I talk about the Pólya. So first of all, show them the Pólya. Okay? For example, you may let them solve a word problem like this. I give you a word problem here. It's a very simple word problem about a train from town E, leaving town E, average speed is 64 kilometers an hour, headed toward town W. Okay? At the same time, another train leaves from town W on an average speed of 80, and then heading towards E. So because there are two parallel tracks there, so they will cross each other. So the route between the two towns is what? 570 kilometers. How much time will it take for the two trains to meet each other? They live at the same time. So this is the kind of thing. See how they will handle it. Go to the 4 steps. That's important, okay? And so they can draw a diagram whatsoever there to figure out how to solve this kind of a problem then. So that's basically what I want to share with you. And another thing, you try to scaffold problem gradually. Don't jump right into it. For example, you start with something simpler, but you increase the level of complexity to build the confidence and the skills. Take, for example, talk about quadratic equation. When you start doing it, very simple, very basic, right? The leading coefficient is 1, easy. They will learn all those methods, how to solve the quadratic equation there. Then later on, you change the leading coefficient to be something else, not 1 anymore. See how they will handle it. So this is the thing here. Then as they can do this one, you go further into a word problem like this. But this one, you give them the quadratic equation. They're supposed to what? Find the time when it hits the ground. Fair enough. So that's what it's supposed to be. So in other words, hit the ground, what means what? X will be 0. Hit the ground. Fair enough? So therefore, they can solve this. But later on, no more equation given them. They're supposed to construct their own equation. Product of two consecutive odd numbers is 143. Find the two numbers. How to do it? They must construct that equation themselves. So that's the whole idea. So you can see that you go from very basic, progress slowly until this stage here. This one, equation is given. This one, not given, but they're supposed to come up with their own equation to solve it. So scaffold them. This to build the confidence in problem solving. That's one of the things you have to bear in mind. Okay? So this is a very simple teaching strategy here. Encourage logical thinking. I talked about earlier on then. And try to justify. Now they can do it verbally or in writing. Doesn't really matter. You see the one I showed you in Singapore, the O level, that one, they put it in writing. Okay, so these are the things here. And it can be more fun. You know why? Meaning something that they can discuss as a group activities, okay, to find the answers. For example, I give you this about birthday party. You think about this one. There are N people in the birthday party. Each person wear a party hat of a special color. Then they can see each other's head except their own. They cannot see what color is their own, okay? One of them shouted this, if you can see at least 6 yellow hats and at least 6 red hats, raise your hand. After he said that, exactly 12 people raised their hand. Question is, what is the smallest value of n? This one, there's no calculation. It's purely by reasoning, logical thinking, how to handle it. Okay? How many people can you think of it? How many? There are n people. What's the smallest value for n? So in all red color have the color. They cannot see their own color. I can see other people's color. Is it if you can see 6 yellow and 6 red? Is it red hat? Yeah, red hat. So raise your hand. And what happened there? 12 people raise their hand. So what does that mean? Of course, if 12 people raise their hand, the party must at minimum at least what? 12 people there first. Am I right? Okay lah. But there could be more than 12. Fair enough. So how many more? Now, there's a question there. How many more? I want the least number. So these are kind of question. Sorry, this is not about LCM. There's no LCM here. So these are the kind of a question that you can use. Anybody from the, hello? Anybody from the, nobody, okay. Yeah. All right, so these are the kind of thing. You can think about it and see what the kids, let them play with it, they can discuss, and then they will, how to find out what's the least number of people in the party. They can find out. See what they tell you. I say, I find, like, put it on the board there and see what they are. So these are kind of activities to help them, to develop logical thinking skill and be able to justify why you think it's the case. They must learn to justify it, that's important, okay? Yeah, explain why. Yes. I won't tell you, you go figure it out. Then you tell me what's that? What's the answer? The point answer is not important. The point is how you reason. That's the important thing. So you know it can be less than 12 people. Since 12 people raise their hand already, right? But it cannot be exactly 12. Why? With 12 people, nobody will raise hand. One. So there must be more than 12. So no, more than 12, right? No. So what can you do? You think about it. What can you do to know how many more? Is it 1 more, 2 more, 3 more, 4 more, how many more? So this is the whole idea. You see, let the kid, that's called reasoning skill, You start with, there must be 12 no matter what. But 12 is not enough because if 12 people there, nobody will raise hand. Because 12 people there, if I'm wearing a yellow hat, which I'm not yellow, when I look out, how many yellow can I see? Only 5. At the very most, right? Yeah.
How many different colors in total?
No, what they want is, they don't care as long as one can see the red and the yellow, that's it. Okay, good. They will never tell whether it's a green head, blue head, no, sorry. These are not counted. They only look at the yellow. Okay? So I'm just saying that. That's why I say there's lots of people. But what it says is, what is the least number of people? That's what they want to know. They don't care about people who wear different color hats. That's not counted. Because if you include all the others, it could be, I know it could be a lot more, fair enough.
So at least 13.
14? I don't know. Okay, how do you now? Good. They say, how do you figure it out? Why 14? That's the question I want to know. How do you figure out number 14? Tell me.
I think from a perspective of a red hat or a yellow hat.
Okay.
You must always see 6 and 6, so you have more of it, it's okay.
14, that means what? 1 yellow and 1 red?
So 7 yellow, 7 red.
If 7 yellow, 7 red, you know what? How many will be raised? 14 hands. If there's 7 red, 7 yellow, will be raised by 14 hands? You think about that. Because the yellow look at it, if 7 yellow, he or she can see 6 yellow. Am I right? He can see there more than 6 red heads, right? He'll raise his hand. It can be it's at least now. At least it can be more, right? So in other words, it will say about 7 yellow, 7 red. That means all 4 of them will raise hand. What? Because everyone can see at least 6 yellow, at least 6 red. Am I right to say that?
Yeah, so the answer is 13.
Okay, it's 13.
You must include yourself.
No, I'm just saying that. No, I'm just saying just to raise, okay? 13. Now, let me see. What color will be the one? Can be red hair, can be yellow hair, right? The 13, Okay, what color will you choose? What color will you choose for the 13? The red color? No. Is it 13 people? How many red, how many yellow? You tell me.
6, probably 6 yellow or 7 red.
Okay, 6 yellow and 7 red. 6 yellow and 7 red.
So I'm wearing the red.
Okay, my question is 6 yellow. Let's say that, okay, 6 yellow. Good. 6 yellow. Let me erase all this. That's quite interesting, okay. 6 yellow. 6, this page is not good. I changed it, okay. 6 yellow, right? And 7 red. Am I right? You see that? Now, let me ask you a question. How many people will raise hand? The yellow, 6 yellow. The 7 red, all right? How many people will raise hand?
If the 7 include yourself, then 12.
No. How many people will raise hand? The 7 red can see all the 6 can see at least 6 yellow already.
Yeah, so 7 people raise.
7 people raise hand. Can the yellow people raise any hand? They can't. Can they raise hand?
That's one.
Because I don't know my color, right?
Yeah.
I only see 5, right?
Yeah.
So you cannot raise hand. But I want 12. I said 12, raise hand. I want 12, raise hand. And just now we said that if I add one more person here, 7, then all together jump to 40 people, raise hand, am I right? Raise hand. You see that? So you can add one more here because, so what does that mean? See, these are thinking process. What does that mean to the students there? That's what the students they can do it like what you're doing, the trial and error. Which is good. That's how they learn how to think, fair enough. Yes, okay. Now let's go to this process. We will be able to go through it. Yes, right. So at least they will say, oh, no, I can only increase the number of people in one color head. Not 2 color. What's the 2 color head? 4 can raise hand already. Fair enough. I can increase the number of people only using 1 color head. Can it be 2 color heads? Because when you increase 1 here to 7, 1 here for the red to 7, you got 40 people raise hand by 6. It's only 12. Exactly 12. Exactly 12, not more than 12, So therefore, the question is that I can only increase the number of people wearing the same color of hat. Can it be of 2 different colors? Fair enough. Now, you can decide whether or not you say, okay, I can only increase the number of people wearing the red hat or the yellow hat. You see the point here?
Yes, yes.
That is the whole issue. And once they see that, what you say is true already. I keep increasing until I hit 12. I stop there. That is the minimum value of n. Absolutely. I take her point. Since you go about 13 there, okay? I keep increasing. If you talk about red 7, this fix will be 6, right? That means I can keep increasing the rate until I get the 12 people hand raised. I stop there. And I count the number of people in the party there. That is the answer. You follow me? So that is a way to talk about it. They can draw a picture if they want to. The kids can just draw a circle to people, right? They count, okay, right? Say how many, okay? The yellow, okay? And then they will have red. So they start with 12, for example. They can start with 6, am I right? 6. Right, 1, 2, 3, 4, 5, 6. Anyway, then it comes increasing one side at the end of the day, right? Either I will increase the yellow or I will increase the red to get to exactly 12 people can raise hand. Here cannot raise hand. Am I right? But when I increase one more, let's say, just as a red, okay? One more. How many can raise hand? 7. Only the red one. This one cannot raise hand because they only see 5 yellow heads, right? This one can raise. 7, right? Now you know what? I can increase one more, am I right? How many? Anyway, I want you to think about it slowly. I follow her reasoning process there.
18.
18?
12 people wearing red hats raise hand. Then plus the 6 people wearing yellow.
She said it. You see that? She followed her lines of thought and reasoned it out slowly. And that is what it counts in learning. And that is what you want the kids to learn how to do. They can just draw by pictures, easy, right? The kids just draw and see, count precisely. So that is the whole reason why, yeah. Okay, fine. They also try to promote, collaborative problem solving, group work, and whatsoever they learn from each other, So these are very famous Fibonacci spiral. They can draw this one, by the way. It's quite easy to draw this one. When they learn the number sequence, they learn the Fibonacci sequence, by the way. But this is a very good number because it appears in nature. This number, Fibonacci number, is better. And they can see this nautical shell. They have this pattern here. And they can draw this picture here, and they can start doing it. This one can be constructed using their geometric set. They can do all those things there. They can do it as complicated as they want to piece up all those little things here. These numbers, what you see here, are the actual Fibonacci numbers in the sequence. So they can do it. Create activities for them to do all this. And that's where they can find the golden ratio. Okay, so this is the one trying to promote collaborative problem solving in group work, and they would like to do it that way. Make learning a bit more fun, have some activities, some puzzles, some games. Okay. Incorporate real world problem. Now remember, math is not real to the kids. Why am I learning math? It's not real. You give them some real world problems. PISA is one good place to look for it. Now, if you don't know what PISA is an international assessment of the students' performance internationally. Every 3 years, they will conduct this one. Okay, and I was involved with the PISA last time, teaching some of the teachers how to help the students in answering PISA questions. Most of them these questions are all real life questions there. Okay, or you can use problems in a real world context used in Singapore context. Now I give you one example here. Very simple example. Nowadays we sell all the smartphone plans. You can go to different phone operator to sign up. Okay, so I got these two plans here. The monthly fee, your call per minute, data, something the kids are very familiar with now, by the way. So you have plan A and plan B. I give you all the statistics there. Okay. Now in a typical month, a customer makes what? 200 minutes of calls and uses 4 gigabytes of data. So calculate the monthly charge of each plan. That's easy. They can do it. Straightforward calculation. Now I say, if the customer reduces his call usage to 150 minutes and increase his data usage to 5 gigabytes, which plan is cheaper? That's very real. Correct or not? So these are kind of a thing. The kids will learn to do it. Again, for a start, you may want to do it as a group activities or 2 persons paired together, see how they would handle it. Then they begin to see that math is real. I'll show you an example of a real world context in the examination. You look at it, this one. You want to give one for Stephen? Okay? Yeah. Yeah. Okay. This is actually from last year's Singapore O-level. You can see the date here. Is October, November 2024. It was last year. Now, of course, this is paper 2, by the way. We have paper 1 and paper 2. And in paper 2, I only give one question. Now, you look at the next page. This is one question, question number 9. Now, look at the information given you. It talks about, Wei starts a small business making candles. He makes the candles by pouring wax and fragrance oil into a mold. He uses a length of string as a wick. Now, table below show information where users to calculate the material he needs. So it gives you all the formula for calculating the materials for the candles, okay? About the mass, about the the fragrance, so on and so forth there. So they don't memorize all the formula there. And they also give them the candle supplies, how much, about the size, and the costs. Everything is given there. So all the tables, all the information given. Now only the questions here, Wei makes a candle using the mold in the shape of a cube with side length of 5 cm. Calculate the total mass of the candle. Okay, the total mass of another candle is 150 grams. Show that the mass of wax used in this candle is 139 grams. So this will work out all those things there. So, and then of course there's a part C. Now part C is the one which is a bit they have to think about it now. They say Wei makes 2 sizes of candle using cylindrical mold. The cylinders are geometrically similar with diameter of 4 cm and 6 cm. The height of the smaller one is what? 8 cm. Wei wants to make a smaller profit when he sells these candles. Suggests a suitable amount for him to change each size of the candle. Justify the decision you make and show your calculation clearly. One question. They're supposed to analyze all the information given them. This is a real life kind of scenario. By the way, you see all the answer here? This actually, I took it from one of the tuition centers. The teacher there, work out the solution for the kids anyway. I want to show you that this type of real life question is set in our O-level examination. And you can see that it's quite long, by the way, okay? So they are supposed to write all, you see, this is a typical solution given by the students there. By the way, this question itself is worth 11 marks. So every year, our O-level paper 2 should have one such question without fail. So now the kids have to learn how to think now. Because this is a real life thing, to be very honest, They will ask you to make a profit, ask them, how much profit that you want to make? 10%, 5%? You tell me why you want to make that profit. Try to justify your decision. So they have to learn about decision making. How to make a decision. Why I make that decision. There's a whole idea about training the students about life skills, put it this way. Using mathematics, teach them to learn about life skills. Is it tough? Tough, huh?
So,
You think so?
from children.
Yeah, for the children. These are the grade 10 students, by the way. Okay, I've ever taught, this actually came out, the first time it appeared in our Singapore O-level is in 2014, the first time it came out. And it was a big hoo-ha, to be honest with you, among the parents, among the teachers, even among the students. Wow, never seen such a question, Taking about half a page there, all the write-up and all the pictures and all the things there. So I was teaching the teachers how to teach this kind of a question. So there's a way to teach them. You see, the whole thing is that the kids must be able to analyze it, number one. They need to analyze the organized information very nicely before they can solve it. All the calculation is very simple. Simple arithmetic, nothing complicated. You want formula? I give you a formula. No need to memorize any formula, I give you the formula. But you work it out the answer for me. So that is what they want. If you make a decision, tell me why you're doing it this way. So this is a typical kind of a question. You can look at it and see, maybe you don't make it so complicated for your kids there. You can make it a bit simpler. Like this one is a lot simpler, a lot shorter, and they can handle it. Okay? But eventually, but in Singapore, we have no choice. All our grade 10 students must proceed to be able to handle these types of questions. And the teacher have been taught how to teach the student to handle this type of question, by the way. There was a time, another one, which I can tell you roughly what this is this lady want to lose weight. Yeah? So you go jogging and walking, and there's a track. There's a track there, near his house there. So I tell you about the dimension of the track, give a so-called a plan, And there's also a rate scale, 1 cm is how many meters whatsoever there. So he said, okay, he will jog 3 times in a week, and then blah, blah, and so forth. And they tell you, if he jog for how many minutes, how many calories will he lose? If he walk, how many calories that he will lose? So he will log, he will jog in the, let's say about how many times, how many minutes during the jogging, and how many times he will jog, so he'll tell you the questions there. And he wants to say, I want to lose 5 kg in a month. The question is, do you think she can achieve her goal of losing 5 kg? Explain. Now, yes and no, you have to decide. Yes, he can lose. No, he can't. No matter what you answer, explain why. You say yes or you say no. Now, you have number of calories and all kinds of things there. The kids said, wow, so many tables there. Distance travel, about all the things there, So these are the kind of a question we ask the kid to decide. What is a real life? So that is what I'm talking about. If you can weave this kind of a learning in your math lessons there, kids will begin to understand why they need to learn math. Am I right? If they solve all this problem, like word problem, all the things they say, still not very real, right? Give them something. And better still, with the hands-on. They can play with it, so much better. That's why I think the STEM trail is good, that they can actually do it. Okay, so I think, and I say last, focus on the process, not the answer. Okay, so that's the whole idea. For example, a student make a mistake in the solution process there, don't give them what is wrong. They're supposed to identify their own mistakes, in other words. Why so? That is important. Not so much you tell, this is wrong. Don't do that. If they can discover their own mistakes, I think they'll learn a lot better than you tell them the one mistake. You know what you tell them? Next day, they will sure forget. That's the whole idea. Okay. Okay, I say encourage perseverance. Now, there's something they would persevere if they get this kind of a question. This is a very classic kind of a question here. You can see that, okay? And they can see whether they can do it or not by fencing an area, and you want to maximize the area. How big it is, okay? This is very simple. No need to use optimization problem in calculus. No need. It's a simple way of reasoning. They can do it. Oh, by the way, differentiation has been included in the E-math already now. The simple differentiation has been there, okay? First time they brought it down to the E-math, but it's only algebraic, nothing else. The A-math still keep the rest of the so-called calculation. This is a calculus there. Now, encourage metacognition, and I say that. Look back what they have done, okay? These are the prompts that you can use. What works? Where do you get stuck? You tell me why you get stuck. Tell me all this thing here. You want to know what they are doing, right? Or they can do it. Can you solve a similar problem differently? Can you find another way to solve problems? So these are the kind of things you can prompt them to let them look back and they will reflect as a teacher. So these are the things which I'm trying to share with you, See, these are not the only questions, by the way, but the whole idea, I don't care what you come up with, the whole idea is to encourage them to do the metacognition here. Okay, I think I better close it a bit earlier. I hope that you find something useful here. Okay, I do it very quickly. I also don't keep it for too long because sometimes I know it's hard to concentrate, so I will let you finish a bit earlier for today. And I can give you today's handout. By the way, here it is, you can take it. Okay, there's not some errors there, it could be over here. Please correct it by yourself, okay?
Thank you.
Yeah, there's some errors here and there, don't worry. These are the calculation errors.